Hello and welcome to Filecoin CryptoEconomics Day here at Devconnect in sunny Amsterdam. My name is Carla Kirsanow, and I'm the lead of the network research team at Protocol Labs, where I've had the pleasure of working closely with the cryptoeconomics researchers at CryptoEcon Lab. We've assembled a fabulous lineup of speakers today to lead you on a whirlwind tour of the fast-paced world of cryptoeconomics and the Filecoin ecosystem. Filecoin is a decentralized storage system designed to store humanity's most important knowledge. And Filecoin's unique cryptoeconomic system is central to its design. Since Filecoin launch, the network has grown to include over 4,000 storage providers with more than 16 exabytes of storage. And the network's momentum continues to grow. Along the way, we've designed a functional two-sided decentralized marketplace, created an innovative first deployment of EIP 1559, and championed scalable Layer 1 research. We're building data-driven analytics for network governance and evolution, developing Filecoin to become a data availability layer for Web3 blockchains, and introducing new Web3 building blocks with new business opportunities in reputation, retrieval markets, data DAOs, compute over data, and other exciting areas. And so, Protocol Lab's CryptoEcon Lab decided to put this event together to share our research findings, opportunities, and challenges with the broader Web3 community. So we'll have about 11 speakers today. That's enough to round out either an American or European football team on a variety of topics, exciting topics related to cryptoeconomics. Each talk will be about 20 minutes long, including time for questions. If you're participating virtually, please put your questions in the chat, and then they'll be relayed to me, and I'll read them out loud to the speakers, if time permits. And so, without further ado, let's introduce our first speakers, ZX Zhang. ZX leads CryptoEcon Lab at Protocol Labs, where he studies the intersection of networks, incentives, and optimization. He'll be giving us an introduction to Filecoin, cryptoeconomics, and its opportunities and challenges. Welcome, ZX.
Thank you, Carola. And my name is ZX, and I lead CryptoEcon Lab at Protocol Lab. I'm super excited to be here. Thank you for all the organizers for putting together this amazing event, and thank you for all the speakers and you for coming to our event. The goal of today really is to kind of showcase, or my talk is to showcase the scope and this range of topics covered by Filecoin CryptoEcon and its amazing opportunities and challenges. Here's our rough agenda. So we start with what is Filecoin to bring everybody onto the same page, and then we talk through some on a high level, some of the CryptoEcon challenges that we face when designing and governing the network, right? Then we talk about some of these latest exciting opportunities, and many of these could be either startup opportunities or like just interesting research ventures. And then lastly, we just covered the agenda for CryptoEcon Day today. Just before we get started, we are hiring a CryptoEcon Lab. Our aspiration is to be this hub that goes from research to protocol and then protocol to product, right? We work with university and research groups on all the general incentive research topics that is central to Web3 and CryptoEcon. And the other really interesting, exciting aspect working in CryptoEcon in the Protocol Lab network is with us, there are always many new interesting upcoming protocol and research in cryptography consensus, which you guys will hear about some aspect of that today, right? And they always call for the need for new incentives, right? Of course, there's always protocol improvement and governance, and then we also participate very actively downstream in the network analytics and ecosystem. After all, the success of an economy really depends on the success of its ecosystem. So so that we're hiring across the board from research, engineering, to product. If there's no role that suits you, feel free to email us, and then we can always carve something out. And then we sort of also champion this CryptoEcon process, design, validation, deployment, and governance, right? So this is something that we kind of apply this systematically in thinking about new problem, and how do we model them? How do we design around it? And how do we know our design is good, right? And then CryptoEcon is really interdisciplinary, as we can see from this diagram here. And then we are looking for collaborators from like different backgrounds and experience. Without further ado, let's dive right in. So what is Filecoin? So there are many definitions of what Filecoin is, and here's I'm giving one that from our take at CryptoEcon Lab, right? Filecoin is, besides being a storage network, we think of it as like a layer one protocol that starts with data, right? And then it's also a multi-sided marketplace enabled by blockchain, which also makes working in cryptoeconomics on Filecoin so interesting because there's suddenly tremendous scope. It's like a live economy running with like different kinds of marketplaces emerging on this system. Right, it's also an island economy, people amassing cloud resources and building new experiences. I want to highlight new experiences. As much as like storage is really cheap and competitive on Filecoin today, right? Like I think for Web3 to win, it's not about cost. It's always about the new experience and new, thinking about new incentive structure, new marketplaces, and that's why it makes it such an interesting place. It's also an Airbnb for cloud services, right? It's kind of like, it's a platform where anyone can become a storage provider or compute provider or connectivity provider, which we'd hear more speakers talking about that later today as well. People kind of like come together on this island, amassing different resources, and then offering this a network of utility to the outside world, right? And it's a really passionate research, engineering, and product community. And I hope like I hope like after today you learn more about our kind of unique opportunity and challenges. You would choose to like work with us. Here's a kind of like stakeholder diagram of like different participants on the Filecoin network, right? Storage providers provide reliable and useful storage and get rewarded by the blockchain for it. We could incentivize other things as well in a decentralized manner, but the other things are much harder to prove. There are many teams in our ecosystem working on like improving the verifiability of these metrics, which you will also hear about later today. But in some setting, like let's say we can't verify completely, can we design like new incentive and new market structure, reputation, and metrics? There are other teams that will talk about this today as well, right? And then a client today, they can only store data on Filecoin, but they will soon be able to do a lot more when a user-defined EVM smart contract coming to Filecoin. We also hear different teams talking about that today as well. And developers are here to build new experiences. As I mentioned earlier, it's not about cost, it's about something new, right? And that's what all these exciting opportunities come from. And token holders stake Filecoin, which is another big opportunity. And the ecosystem partner create a myriad of initiatives to jumpstart the ecosystem. So this is like a comparison with Filecoin with other storage networks. As we can see within the Web3 space, that pretty much is like a dominant player. But however, from our ecosystem perspective, it's not about Web3 versus them, but more about how can we bring even greater adoption from the traditional web, right? In comparison to AWS, right? Well, I think we are only another 10x to go to catch up to the size of AWS. And also just to call out, right, all this capacity and adoption was only amassed in slightly over a year, which showed this tremendous power of cryptoeconomic incentives. But we are still just getting started in our quest to like build greater adoption on a Web 2 scale. And Filecoin is a layer one, so we implemented a version of EIP 1559 roughly a year before Ethereum mainnet. We back then we had a set of requirement of our gas model, and it checked the boxes. So this is like the kind of the network transaction fee on Filecoin since launch. At its peak, as we can see, it's actually consumed more than 200,000 Filecoin in a day. And then there's an interesting dip here, which I think some of us will talk about this as well. And then and how do we really design? Basically, the short context here in the interest of time is Filecoin introduced an upgrade that scaled the network 10 to 25x at this point in time. But then some other things happened such that the network ended up consuming less fees. But we believe this is long-term good for the network because that makes it cheaper to participate in the network. And this kind of tie into something more interesting about blockchain gases in a world where scalability is no longer a constraint. One of our researchers will talk about that. How do we think about the new gas model from a CryptoEcon standpoint when blockchain scalability is no longer a constraint? So with this brief overview of Filecoin as a layer one, it's a marketplace, an Airbnb for cloud services. There are many things we can provide beyond just storage. Now we want to talk a bit more about what makes working on Filecoin CryptoEcon challenging. I think it really boils down to like we try to do some the network, Filecoin network as a whole, or also the protocol lab network as a whole, envision to build network of utility, right? We want to make blockchain useful, and then we want to make blockchain internet scale, right? So instead of like the blockchain merely just execute the transaction, there is something that blockchain wants to do. Right? It's about like building an economy. It's about create something of value, about kind of like empowering traditional businesses, right? So that's what a lot of our kind of goals and constraint challenges come from. And we want to do it in a decentralized, permissionless, and a trustless ways as much as possible. And that's where a lot of our constraints come in. But progress as a community, right? As we have like more than 4,000 storage providers, more than 10,000 developers building our ecosystem. And then we exceeded 16 exabyte of storage capacity with more than 70 petabyte of data stored, right? And then you have a global community of like storage providers. And also something that struck me during this Devconnect was, I think maybe like a year or two ago, the CryptoEcon community was tiny. But I think during this time in Amsterdam, we actually see multiple projects working on very similar issues within the Web3 ecosystem. And then we hope that throughout our talk today, we get more people excited, interested in working in Web3. So I just want to talk through some of the high-level key economic policy that we kind of we picked and some of the consideration that went into it for Filecoin, just to give people a glimpse of some of the trade-off and consideration that have gone into it. So the biggest lever that we have is a block reward policy, right? Like before Filecoin, most of the crypto system kind of adopt something of a flavor of an exponential decay, right? It came from the Bitcoin land, right? The early adopter gets disproportionate reward, and then like it goes down from there. We identified a few issue and constraint with this early on, right? Like sometimes when you give the most reward at the beginning, the network is the least mature, and it's also the smallest in adoption, right? Like we want the network minting to kind of be aligned with the network's utility. So together with our collaborator at Block Science, we innovatively came up with this mechanism called baseline minting, where the block reward is minted based on the network KPI. And then in the case of Filecoin, because storage is the only thing that we can prove, we have this exponentially increasing baseline, which is a target, a KPI, that the network needs to hit in order for the minting to be at its maximum potential. So in reality, the network will be minting somewhere in between these two bands, right? So like we are minting based on the utility that the participant provide to the network. So this is like, here's some empirical data. We are like more than 1 year in. So the network started with below the baseline and it catches up to the baseline in April last year, right? And then we can see like the block reward was kind of the per epoch reward was low in the beginning, and then it slowly climbs up, and then now it's following exponential decay based on the initial promise once the network is crossing over the baseline. So the area under this curve, which is this part that's invisible here, right? This whole section are reward that were not minted because the network was not hitting its KPI, and all the reward here are being spread across to give more sustainable reward in the future. The other important policy is collateral, right? We want to align all the storage providers' incentive with the network. So we want to make sure the storage is reliable, which turns out to be pretty reliable. We want to make sure people are not violating the consensus security of the network. So there's both the initial storage collateral, but there's also the initial consensus pledge collateral. So this is how, on a high level, how people mine or become participant of storage providers on Filecoin, right? They acquire the token. They kind of like commit, let's say like when you have the supply of storage, but there's no demand for it, you basically put that into a storage container. We call them committed capacity. You put in some Filecoin as well, and then you commit to the network and say, hey, we are going to prove this amount of storage on the network, and here's my collateral. And then when demand comes around, people can then say, oh, and I will take out my container, and then I can slot in the demand, I can slot in the deals. The analogy here is like empty Uber car driving on the road to demonstrate, hey, we have demand for all this, we have supply for all this capacity. And then when a client comes around, they can flag down a Uber and say, hey, I want to get into the car. So this is made even more true with Snap deals. Now people can just slot in their useful data into the capacity on Filecoin. And then 1 year in, like we lock, I think more than 120 million Filecoin. on the network as collateral. If you compare that with like any of the DeFi protocol, you'll be easily ranked as among the top 5 across all Web3. But this is another aspect that people don't talk so much about Filecoin. And then this is also the percentage of the circulating supply being locked in Filecoin. Again, there's also major opportunities here as well, but I think some other speakers, they will speak more about them. Then the other interesting aspect is like slashing policy, right? This is also pretty interesting. So people, before Filecoin launch, people always talk about, oh, how do we guarantee some kind of quality of service on a permissionless network? And then it turns out CryptoEcon is to the rescue. So on a high level, the Filecoin blockchain will come around to every storage provider and ask them, hey, you said you're storing my data, where is it? So the provider will say, hey, here's a proof of me storing it. And then the blockchain will check, okay, good, you have it. If not, oh, no, you don't have it. And then you get slashed for not storing the data that you promised to both the clients and the network. So on the right side, this is the chart of like the daily faults on Filecoin. As we can see, the shape of this chart highly correlate with the daily fault penalties on the Filecoin network. And then later on, I think there's another talk that talks about penalty and how Incentive is doing a really good job in making sure the Filecoin storage is super reliable. And then there's also gas policy, because after all, it's a layer 1, right? Like we implemented ERP 1515 variant. And then like we had like 2 other variations here. One is this overestimation. We started since Genesis. Basically, it has to do with how the VM execute messages. We are not going into details. And then we also introduced a batching dynamic, because Filecoin is that's my personal take. It's one of the most scalable chain out there. Sometimes like from the CryptoEcon Lab, we sometimes will ask our engineer, hey, can we slow down the scalability so that we let demand catch up to the chain, right? But we introduced this like 10x, 25x improvement in scalability earlier last year. And then we also introduced a batching dynamic to kind of like to balance out the incentive misalignment. There's a whole separate talk there that we're not going into, but like that's something interesting. Some of this innovation that we did and modification that we have done to the gas policy. There will be another talk, I think, by the block science team on gas later today as well. So another challenge with, so we talk about all the policy side, but well, unfortunately, as like crypto economists, our job is not done once the protocol goes live. There's still like governance, there's analytics. So we also developed this like Filecoin improvement protocol in thinking about governance. How do we decide what policy go into the system? So FIP model after EIP, Ethereum improvement protocol. Anyone can propose a FIP. But then sometimes it's like a FIP could be seemingly innocent, or it could be universally positive, but then they actually have a very profound CryptoEcon impact, right? So we also develop a governance process within CryptoEcon Lab, and which is we start from, we first take a look at the idea, we perform a smell test. Does it smell good for the overall economy? And then we do an impact surface assessment, right? Like if it's a very small impact surface, but it's also a very big improvement, then it's a no-brainer. But then sometimes a big impact also comes with a big impact surface, and then we need to go into a lot more considerations. And then we do analytical analysis, where sometimes we just modeling, writing out the analytical equation, which you will see quite a lot from our colleague today in the various aspects of the work. And then one step further, sometimes we need to do modeling and simulation as well. The challenge with CryptoEcon sometimes is there's no right or wrong answer. And then the outcome can also depend on many external factors, as we can see from some of the hyperdrive examples. But of course, we also invest a lot in analytics to make sure that whatever policy we pick as a community, we have like real-time feedback on how we're doing. And analytics can also inform where are the most needed areas of the network and how can we improve network governance as a whole. We'll hear from Starboard team later to talk about how we apply analytics in network governance. There's a dashboard, and then there's also both from the network level dashboard and also from the actor level dashboard. Then this is also like about how people behave and spend in the network. And this is something, another call to action here. In the traditional web world, people really study data to its bone, right? Like everything is getting analyzed on the traditional web. And in the case of Web3, everything is public, right? Everything is public, but we are not spending nearly the amount of effort trying to understand what's going on and how do we use those insights to make better informed decisions, and how do we improve the welfare of everyone in the ecosystem. So there'll be more talks on this topic later today as well, but I highly encourage you guys to check it out too. Now that we talk about all the challenges within CryptoEcon and Filecoin, let's also talk about the opportunities. So as I mentioned earlier, Filecoin is one of the most scalable chains out there. Even today, Filecoin is the largest deployed SNOC network in the world, right? Like we hear talks from our cryptography team later today as well, talking about some of the new direction that they are checking out. And also, as I mentioned earlier, we did this 10 to 25x increase in scalability earlier last year, and then there are more up in our research team's sleeves. Given this kind of increase in scalability and in the parallel to the Ethereum world would be like, what happened to Ethereum after all the roll-up solution comes online, right? Like how would it impact the macro of Ethereum as a whole, right? So this presents lots of interesting questions from a crypto economic point of view that's not frequently asked. And later today, there will be I think right after this talk, there will be a talk on how we're thinking about new gas models in the post-scalability world. Another unique value of Filecoin, in my opinion, is really like this verifiability of data, and you have a proof that data is online every 24 hours, right? So in some sense, in my mental model, where a CID, which is a content identifier, which is a unique hash of the content of a piece of data, right? Like in my mental model, an NFT is nothing more than a unique representation of some digital content, right? You can technically create new interactions beyond just trading on NFTs, and then you bring the value back to the content itself, right? So you have this pretty unique building block that coming onto Web3, where you have like verifiable content that's being proven every 24 hours. And what are some new interactions that we can build with this? And I think we have another talk today that dedicate towards this as well. And this is another interesting building. This is kind of illustrate what we were talking about earlier. You have this IPFS layer of like CIDs, which is the hashes of the content, and then you have the Filecoin layer, which bring you the proof and the internet level scalability, right? Previously, people can try to do bridges to other smart contract platform where you can build a business logic that opens the door to a whole range of business applications. But even more exciting updates, user-defined EVM smart contracts also coming to Filecoin, right? So this is what we call FEM projects, where now you have smart contract and also like provable storage. So kind of a challenge to the audience is Web3 evolves in waves, right? Every time there's a new building blocks, we get excited about them, but sometimes we haven't figured out what do we do with them. This is the case of ICO in 2017, and then that gave us to DeFi and CryptoKitties, NFTs. Right? A challenge here is now we have a new unique building block. What are some new experiences can we build? And then we have some other speakers sharing their kind of perspective and ideas here as well. And lastly, we have massive amounts of data massive amount of data being stored. And then how can we? And then now people are also building different retrieval markets on top of that to really retrieve this data. And then put in the context and use cases that they're using, right? So my personal take here, the retrieval is really context dependent as well. It really depends on the use case. On a technological level, nothing that stops data from being retrieved. It's more so like a business use case, more so like a product market fit kind of question. But the good news is there are many teams working on this, and then we also hear another talk today by Patrick talking about retrieval markets on Filecoin. And lastly, today is Filecoin CryptoEcon Day. Today is the day you guys at the right spot. I'm very happy to have all of you here. As I mentioned earlier, where like in maybe just 2 years ago, it's very hard to put together a CryptoEcon event. There aren't that many people in this space. I'm super excited. Now we have more and more talent, developer, researchers, mindshare interested in CryptoEcon. And I hope I have sufficiently convinced you in the context of Filecoin, there's so many exciting opportunities and challenges with CryptoEcon. And with that, thank you for your attention.
Great, thanks for that, ZX. That was a great introduction and overview to the content that we'll be enjoying today. I don't think we have time for questions directly to ZX, but I'd like to point out that we have several members of the CryptoEconomics Lab here today if you want to ask them in person during the break, and many of the things you may have questions about will be covered in the upcoming talks. So we'll move on to our next speaker, Axel Cortez-Cubero, who is a research scientist at CryptoEcon Lab with a background in statistical physics. And he'll be speaking to us today about a gas model for a post-scarcity era. Take it away, Axel.
Right. So, okay. So everyone hears me okay? Okay. Wait. Right. So my goal here is to introduce you a problem that maybe you don't know you have, and then not give you the solution to that problem. But I just want to introduce the possible space of solutions for this kind of problem, which is, as in short, is maybe there's a lot of people focusing on how do we scale the blockchain, make it more powerful. But basically, to understand what could be the problems associated with that, or if we want to think maybe not just scale as much as we can, but scale as much as we should, is a question. So I just I'll talk a bit about gas in general. So yeah, just very briefly. So gas is what I mean by gas is just like a unit of computational effort in the blockchain. So like all these transactions, all the nodes need to validate that it takes effort, everything that is included in the blockchain. Right, so it is the amount of gas that you could have in every block, right? So it's that you could use in every block. It's precious. It's scarce, so there's only you cannot put all you want in there because everyone needs to validate this, right? So the point is it's scarce, so it should be optimally utilized in a sense. So the idea is that there should be an optimal block size that you should. So this is like the amount of gas that we can all fit in a block, and we can handle it. Anything more than that, and it's too much for the whole network to process. Anything less than that, and the network is being utilized, and that's not efficient. So it should be used better. So the idea is that so you should price so it should be used optimally, and the way that it's done is basically it should be priced at a market clearing price. Right? So the idea is that the amount of what you should pay for a unit of gas should be the optimal value, such that only the amount of transactions that fit in the block size that you're aiming for can afford this price. Right? So anything else would be priced out. Right? So so the idea is that you want to select only the most valuable transactions to be included on the block. So you move the price until you reach that price that only this exact block size makes it through the market clearing price. So this is in a normal limited blockchain where you have scarce gas, like only this amount of block size available. So the next question is, so how do we kind of reach this market clearing price? There's different approaches to this. So there's the original Bitcoin approach is just a first price auction, which basically amounts to everyone just makes a guess about what is the market clearing price. Right? So you submit your transaction and you make a guess. This is what I think this is worth, and everyone out there makes a guess, and those with the higher guesses get through. Right? So that's how this works, and that's a mechanism that has worked okay. But the idea is that this tends to be very volatile, and people aren't great at estimating. Right? So you might end up overpaying, and so that the prices can fluctuate more. So then, so the approach we're using in Filecoin and in Ethereum as well is this called EIP 1559, where the idea is that so you price gas not just by the amount everyone voluntarily guesses, but you have a base fee which is set by the network. So this is posted. This is the base amount of fee that you need to pay for your gas, and you can put something on top which is meant to be just to cover the marginal costs for the miner to include your transaction, right? And then this base fee, the idea is that this is now not paid to the miner, but this is burned, and this evolves in some like definite algorithmic way, with the point being that this is adjusted based on demand on the network. So in this case, you allow the block size to be a little bit flexible, but you set a target block size, right? So this is the optimal block size that I want. And if in a given block I spent too much gas, then I raise the price such that the next block will be closer to where I want it to be, right? So this adjusts the base fee such that the idea is that this mechanism should equilibrate close enough to the appropriate market clearing price. Because these are different options you have. But so this is what we are using in Filecoin. So one point is that so this price doesn't come from these mechanisms. So one of these shouldn't, this EIP 1559 will not make your transactions cheaper or anything. Where this price comes from is just from supply and demand. So these are two mechanisms just to try to find out what the price is, but they are not what is used to determine the price. So the price is simply just supply. So in a fixed blockchain, like we were talking about with a fixed with a target block size, supply is fixed, right? So this is the amount of gas I have per block. Then if more people want to use this, if there's more demand, that will lead to a change in the price. Right? So this is basically the kind of a symbolic equation showing the dynamics of so if there's a change in demand, if demand increases, then I should increase the market clearing price such that I remain at my target block size. And if it's demand reduces, I should reduce the price. So that's the idea. So one question that we think about right, as crypto economists, that maybe many engineers think less about is like, do we actually want to decrease the market clearing price? Right? So this is a big complaint. Okay, gas fees are too expensive, and so on. So we could tell the engineers, okay, make it scale everything, make it better, make the blocks larger so we can fit more stuff. And that should give us a lower market clearing price, right? And that's something like CX described is kind of what happened with this hyperdrive, that suddenly we have this boom. Now we can process 25x times the amount of gas in the block. And the question is this something we should do? Is this a good deal? Right? And then we need to think about what is a good deal. Right? And the reason why you might think, so yeah, it makes sense. Let's make it everything more scalable. We can include more stuff, but there's something you're losing by this scalability, which is you are reducing your market clearing price. Right? So miners will complain that, oh, why did you make it so scalable? Now I'm making less money. That's the idea. Right? So yes, I want to think a bit about. So I want you to think about this question of what is a good deal for the network. Should I always scale, or what should I do? So, one strictly economic way to think about this question is just to think about the total network revenue. Right. So the idea is that if I increase the supply, the market clearing price will be reduced. So this is bad, right? People are making less money, but the idea is that now more transactions can get processed, such that sure each one will cost less, but there's more being processed, so that's a net good, right? So you can think of it. So what is this total network revenue? It's just like what is the current price times the amount of transactions that you could process, right? So if I scale and this gets lowered, but this gets increased enough that overall this increases, and that's what I would call a good deal economically. Okay. So for instance, this is what didn't happen right away in this hyperdrive that CX talks about. So you scaled everything, the base fees went down, and the demand to reach that level that we needed, the 25x, is still working to reach that level. So that's what could be considered a bad deal. So you might question, like, is this are we being superficial here that we're just like a good deal is just make more money? But for now, we'll leave it. Okay, so this is something to think about, but that's one goal we could use to work on. But I think it's not that superficial in the sense that so what we want is we want to have like a healthy and very useful and active network, and that involves miners being motivated, right? So if the revenue is good and rewards are good, the miners will be motivated. There will be more miners or storage providers, in our case in Filecoin, joining, and they need to be properly motivating to bring more miners and make it a good network. So the general principle that I guide myself with is so the supply that we provide by all these scaling solutions should be just appropriate for the level of demand of the network, not like much higher than the demand there currently is. So just a little summary here of kind of a typical scaling solution that we can see in the blockchain space, but it's just like making a roll up or a side net on the. So the idea is that so if you have your main net, your Filecoin or your Ethereum or whatever, and this is too expensive to use, you can like make your own little side net where you run your sub transactions in there. So this is what happens like at an exchange or something. So okay, so this exchange is gonna make all these transactions, and then only at the end report the final result of that to the mainnet, right? And this allows you to do like more transactions, maybe at a faster scale. You can do more things without reporting each one of those, without using gas on the mainnet for each one of those, right? So you only spend it here, and then report only the result after that. And so that has a result. So having many side nets like this could take some demand away from the mainnet, right? Because these are all transactions that could have been performed on the mainnet, but now they don't need to be performed there. So that's something to think about. Right. One point of this is that, right, so the sidenet that you're running your sub transactions in should have a lower market clearing price than the mainnet. If not, like users would just go back to the original net. But the trade-off is that the mainnet is expected to be like with the higher security and a better reputation, right? So that's why you want to report back your final results to the mainnet and make them more permanent there. So this is the idea. So the subnets should be cheaper, but less security, less reputation, and so on. So that brings me to this is a project that we're working with. It's mainly Consensus Labs of a project that. So it's a solution we are working in Filecoin that this could be what scalability looks like for Filecoin, which is what they call hierarchical consensus. And the idea is similar to this stuff about side nets that I talked about, but just more hierarchical, I guess. So the idea is, so here you have your main net, which I guess this represents time or something like that. But anyway, so here you have Filecoin, let's say, and then I have more demand that I can handle here, so I spawn a subnet here. So I can spawn a subnet, and here I process transactions fast, and then I am checkpointing total results back to the mainnet, but not everything that happens here. So similar to the side net rollup kind of thing. And so here, this one has two subnets, but then the idea is that when there's too much demand here, also these ones can spawn their own subnets, right? So, and then these ones again could spawn their own subnets if they want, and so on. So this idea of hierarchy of nets, that how they are connected is basically so this one runs their own sub transactions, and then periodically they post their checkpoints back to their parent net. Right? So this interaction subnets checkpoint back with their parents. So the subnets remove some demand from the parent, but then they also ask for something because they need to spend some gas on checkpointing with the. So there are checkpointing gas fees when they checkpoint with the parents, and right. So the idea is also that the parent chain should provide some level of security and reputation through to the subnets by keeping track of their checkpoints, right? So they're saying, oh, this there is some more permanence to these transactions, and also there will be collaterals that can be slashed to start running this net. So you can say, okay, so I want to start a subnet. If I want to start an official subnet with this parent, I need to freeze some amount of collateral that may be slashed by the parent if I do something bad. Right? That's the idea of hierarchical consensus. Sorry. Right. Right. So the idea is, so now the hierarchy is limitless in principle, so I can keep spawning more subnets whenever I need it. There's no supply problem anymore. All scalability is solved, right? So that's the idea of this. So I grow, the hierarchy grows as needed. And then, right, so if I'm a parent chain that have my own subnets, I can kind of pull on them if I feel so. I have some controls over my children nets by their checkpointing fees that I charge them and by the collaterals. So I say, if you want to start a subnet under me, you have to pay a higher collateral. So if these fees are high, it could discourage the creation and survival of such subnets, right? So I make things too expensive for the subnets to survive. Or if I want to spawn a lot of new subnets to take care of all this demand, then I make these things cheap and they can join. Right? And then the idea is that while the whole hierarchy is limitless, there's no scarcity anymore. Each of the nets in the hierarchy is a finite net that each of them should be utilized optimally. And then kind of the guiding principle we want to use is that the overall total network revenue of the whole hierarchy should be maximized. So growing this hierarchy should be in the name of it being better for the whole hierarchy. So that's the idea. Right. So we can think of the model here. What we can do about this. So this is the traditional model I told you about like a single chain that more demand brings higher prices. And this is kind of how this works in 1559. That this is the market clearing price is adjusted by depending if the block size was bigger than the target block size, then I increase the price and so on. So this is this dynamic for this simple case, and what we're looking at now looks more something like this. So this is for a given chain, for a given net in the hierarchy. So these are kind of the knobs that you have here. You have your base fee, your normal gas fees that you charge for transactions. You have your checkpointing fees, and you have your collaterals. And you should adjust these fees based on what's happening with the hierarchy. So this is the data that you read to make your choice here how to adjust it. Right. So this is kind of the solution space I was talking about. Right. So each of these nets must keep their. They have an individual goal of like keeping the optimal block size for myself for that one given net. So that can be a EIP 1559 like mechanism. But then also they should have in mind like what's happening with the whole network. So it's a collective goal. So okay, the total network revenue is increasing. And if that happened because I see that more, so this is the total amount of gas being spent in the network. If more gas was burned in the network and that was good for the revenue, then I want to incentivize that more. So I would make these fees, checkpointing and collaterals lower, right, to invite more growth. And if growth was bad, then I want to pull back. So this is kind of the idea. And so you can, so this is the main picture here. And this is not the solution because I'm not showing you like an exact formula like this, how to play, but there's many options of what we could do that will look like this, but this is, should come from something like this. So So this is my final answer. So how large should the hierarchy grow? So it should be large enough and maybe a bit larger to maybe induce a bit more demand, but it shouldn't be larger than it needs to be. And that's about all I have to say.
Great, thanks for that, Axel. And I think we have time for a couple of questions, actually, to the speaker. And so we'll do this Oprah style. If you raise your hand, I will come at you with the mic. Or I will lead with my own question. You mentioned that Subnet's inherent reputation and security features from the mainnet. Is the reputation and the security features of the subnets, are they strictly dependent on the mainnet? Is there any way for subnets to compete on features other than price?
If you start a subnet without, but what I mean by this borrowing of reputation is just that you checkpoint, so you have a level of permanence that you know, okay, so the users of this subnet knows there's something more permanent happening in the parent net. And also that you know this subnet paid some collateral that can be slashed if they misbehave, so you know they're motivated to behave. It could also become, the subnet could become more valuable than that by providing a valuable service, right? So you also, that subnet becomes a good subnet that is doing something good. People want to use it. So this is kind of a minimum value that you know, that the user knows the subnet will have, but the subnet can grow even above these values. That's the idea.
Fantastic. Thanks again, Axel. One more question over here.
I'm thinking about like the collective goal of maximizing the revenue of the network and wondering if there's any ambiguity in like how to measure that, either what the elements of the network are, not just miners and computers, but humans, and like how you measure revenue. Is it only in Filecoin, or are there other currencies?
Right. So this I guess this comes back to the question of the superficial goal or not. So the idea here is kind of, I'm assuming, so the different subnets can actually do different tasks, right? So let's say we have Filecoin that is about storage, and then so you make a subnet that is focused on retrieval market, and you're incentivizing people who retrieve files and so on. They're doing different things, but they kind of what joined them, what we can measure them equally with is the amount of gas that they spent. Right? So it's just like on the computational power required for each of these things. So we're assuming that the computational power of all of them can be measured and compared. And so this is one simple goal, which is okay. So this is my definition, but now so now in the hierarchy version, this would be a sum of these guys over all the subnets in the hierarchy. So what's the market clearing price of each of them and the block size of each of them? This is again like a very cold economic target, but it's one to work with. Could be, it's also open to maybe this is not the right target.
Thanks again for that answer. I think now we'll have to move on and introduce our next speaker. Also from the CryptoEcon Lab, we have Tom Mellon, who comes to CryptoEcon Lab from a background in theoretical physics and computational chemistry. He spent the last couple of years modeling infectious disease, and now he will be talking to us about fair prices for perpetual storage. Yeah. Take it away, Tom.
Cheers. Thanks very much, Carola. So I'm going to talk about a fair price for perpetual utility. So what does this mean? So I'm just going to change my screen because we seem to be sharing the presenter view. No problem. Give me 1 second. Okay, there we are, no problem. Okay, so a fair price for perpetual utility. What does this mean? Okay, so utility, first of all, from the user perspective, this is the expectation of access to a service now or at some time in the future. From the perspective of the storage provider, or what you might think of as a miner and other networks, utility block rewards essentially are one in proportion to the utility provided. So utility, what we're thinking about here on the Filecoin L1, it's data storage, which gives a decentralized and robust and efficient foundation for humanity's information. But elsewhere, it could be other things. So it could be off-chain compute, it could be networking, it could be attention. But focus here is on data storage. Okay, so Perpetual, what do I mean by this? So Perpetual is a pretty high target. I mean, keep things in context. I mean, I think it was like in the 50s that when Shockley got the Nobel Prize for the transistor, you know, progress has been absolutely massive. So who knows where we'll be in 50 years. But as an absolutely serious target, we do need reliable long-term storage. I mean, you can see the kind of motivation from this in terms of the societal value. I mean, if you want to store important information, election results, humanitarian data, environmental records, you need to do this in a long-term way, and this kind of relies on securing a chain of evidence, relies on immutability, and it relies to be able to store on a scale of decades to ideally hundreds of years. Okay, so price. Price we're going to talk about a little bit. I'm going to skip over this slide for now, but there are different things to think about there. I think an interesting aspect of this is what we think of as the fair price. So, okay, sure, you can just say the fair price. This is kind of the market equilibrium between supply and demand. But I think, you know, we can do a bit better than that. I mean, in order to come up with a fair price, you have to be able to give some assessment of what the underlying factors are that determine the price and what this is likely to be in the future. And that's not simple at all. So in order to come up with a fair price, I think we have to be informed and we have to have sufficient models and information to do this. So there's fairness in this aspect, but there's also kind of a wider point as well. So fairness generally has not been the domain of economics, as pointed out here by Kahneman and Thaler. But I think to make a kind of wider point, we have an opportunity to do something different here. In general, Web 2 economies have been based on this kind of principle of information asymmetry. You don't really know how your information is being used. Take, for example, AWS for one example. I mean, it's easy to get your data in there, very low cost, but getting your data out, kind of different story. And this same story is seen across Web 2, but I think with Web 3 we have a chance to do something completely different. Everything is written in code in a transparent way, and the incentives are laid down in a completely transparent way that's much more equitable to the different parties involved. So I think there is really an opportunity to have a much fairer take on long-term storage and other things in Web3 generally. Okay, so that's kind of the background. Some of the things that we can think about whenever we try to examine long-term storage are, sure, there's the mission. This is what's motivating us. We want to have long-term storage for humanity's most important data, and to an extent, the principles with which we will develop this is motivated by fairness and encoded in the crypto-economic incentives, in the carrot and in the stick, in the collateral and how this is slashed, and the block rewards that are earned. But some other aspects that we have to kind of drill down into, if we want to price something like perpetual storage, fundamentally you're relying on people having hardware, having disks, buying bandwidth, having physical facilities. So that is something we have to consider if we're going to think about price, as well as other things like redundancy and how we might use some DeFi ideas or funding ideas to structure how the long-term storage is paid for. Okay, so first of all, the basics of the crypto-economic incentives. Storage providers earn block rewards in order from storing information, but if they don't store it reliably, their collateral can be slashed. So you can see here that if we examine the chain, you can see how effective these incentives are. So okay, sure, anybody can have a fault, even good miners. A hard disk can fail, or electricity can be cut. But you can see here the incentives are effective. because, for example, for this miner sector that's shown, I don't know if you can see it well, but for this miner sector that's shown, okay, there's a fault, but then that fault is recovered the next day. And then, okay, there's another fault, but it's recovered again. So the incentives are incredibly effective. They're virtually always fixed, but there's also sufficient slackness in the system that good miners, if something breaks, they don't get penalized straight away. So this is kind of basics of cryptoeconomic incentives and determining these parameters and how big the faults fee should be and what the delays are. This is something we try to determine through simulation. But I'm not going to go into that today. I just wanted to set out the basics of the incentives. Okay, so how do these incentives actually affect the price? So one aspect of this is hardware costs. And this is kind of an interesting little problem that came up whenever I was in Las Vegas last week talking to some of the storage miners. One of the things they were telling me about is, okay, we've got these hard drives and these hard drives fail sometimes. And they have a warranty, and the warranty is 3 years. So there's different kind of options they can take. They can have a strategy where, okay, they replace it within warranty, or they just wait as long as possible and let the disk fail. But you know, there's a kind of different outcome from each of these strategies, because if the disk fails, then you know it takes some time to replace, and then you're open to A, losing block rewards, and B, getting your collateral slashed. So it's kind of like under these kind of different trade-offs. Like if you buy a new disk too early, then you've got to pay more. If you wait too long, of course you've got to pay less for disks, but you've got more chance of having an unplanned failure and getting slashed. So under this kind of situation, what's the optimal strategy? So one way, so part of what I'm doing here is I'm not going to give you a price that is $10 for storing something forever, but I'm going to set out some of the methodologies to think about this. So one way you can approach this kind of optimal strategy problem is to treat it as a renewal reward process. So as time goes on, disks can fail after a random amount of time, and they can fail it with different. They can stop working via different modes. So they can fail or they can be retired. And whenever this happens, there's different ways that you can realize costs. It can be through having to buy a new disk, or slashing, or block rewards. So to make progress in this, we can use the renewal reward theorem, which is given here. Okay, so yeah, we can use this renewal reward theorem, which states that the expectation of this process is given in terms of the expectation of the costs divided by the expectation of the disk's lifetime. So good, but expectation over what? Expectation over some distribution. So we can model this distribution as the kind of classic failure distribution from reliability modeling, which is this kind of bathtub-shaped curve, as you see here. Now, to actually model it, we can model it as a stretched out beta distribution. Okay, fine, we can do that. So now our optimization problem is we want to optimize this functional. How can we do this? So we can't do it straight away because we don't know what the expected cost is and we don't know what the expected lifetime is. But if we break it up into the different modes in which the expected lifetime can be realized, then we can work these things out. So if we kind of expand that expected cost into the different ways that it can occur, and we expand the expected lifetime into the different ways that can occur as well, then we've got something that we can easily evaluate. And if we do this, we can find this optimization problem, plug in some numbers, okay, warranties 2 years, 3 years, whatever, and find an optimal replacement policy for that disk. So this kind of feeds into knowing how long you should keep your disks for, informing miners, and of course it can feed into cost models. So another approach we can take to think about factors that affect price over a long period of time, again, is hardware. And so for hardware, physical media, we have price information. So we have this kind of Moore's law-esque time series data. I mean, as you can see here, over the past 20 years on this log scale, it's effectively linear. Now, will this continue? I don't know. But you have to assume something. You always have to have assumptions in models. And if we have this assumption, can we somehow use it to inform what the price of the Filecoin deals might be in the future. So Filecoin deals, I mean, they've only been around for about a year. So it's kind of difficult to imagine how they might go in the future, but of course hardware is an underlying factor. So can we use this historical data to inform what the price might look like in the future? And yeah, sure you can. So we can make it like a simple generalized linear model. And if we do this, and we have some partial pooling of the coefficients in the model, so we can say, okay, we're going to let the slopes of the historical data for disk drives inform what the deal prices might look like, then we can come up with some kind of trend for the future. Yeah, thanks. So we can do this, and of course we get a distribution. If we integrate these forecasts in the future over all of the different realizations from the MC inference, then we can work out a distribution for costs of storage in the future. But of course, this is kind of limited because this is not the only factor that affects deal prices. There's so many other things. You got to think about electricity. You got to think about bandwidth, as well as just a market perception of what the demand might be. Okay, so that's one factor. Mostly what I'm doing here is kind of setting out some tools and frameworks for ways that we might think about this. So slight change of direction. Another factor is trying to consider how we might fund this. So one way to fund it is in terms of a yield-bearing token or some kind of bond. So how does this work? This works, so instead of paying for the price of the storage fully upfront, is there some way that we can distribute the payments into the future using the interest from a bond, for example? So it's going to be something that's very stable, that produces a yield every year, and that can continuously be drawn from. So if we invest in a bond, we expect to get something like this, where the value of that grows over time, as stated here. Now, this kind of growth satisfies this simple differential equation, but what if we don't just let the bond grow and instead we deplete it over time by using the interest to pay storage providers? So instead we get this kind of little differential equation like at the bottom. So now the kind of question becomes, okay, so if the client who wants to store data buys this bond and uses the interest on it just to pay the storage provider, what does this look like? So how much do you need to put up for the initial bond in order to pay for the storage? So this effectively comes down to saying something like, okay, can you solve this equation under conditions, for example, like what I want is the bond to pay for the storage and for this to be completely depleted over the lifetime of the storage, for example, 100 years. So we can solve this. We can solve it, but only if we make a lot of assumptions. So we still need some kind of model for what the storage is going to look like in the future, for what the deal prices are going to be. But if we assume that the storage price goes down very slowly, then we're kind of got this scenario. Yeah, so if we do make assumptions that it goes down very slowly, then we're in this kind of regime where, okay, you've got to pay a lot if you have low interest rates, or if you've got a very high interest rate, you can pay less. And you can work out what these curves are and where you sit on it. But fundamentally, we have a kind of tricky problem in that, A, we don't exactly know what the risk-free rate of return should be, and B, we don't precisely know what the fundamental costs that feed into determining the price of storage in the future are going to be. So these are all things that are assumed, but sure, we can come up with a model that changes the funding and how the cost is distributed over time. But there's more to it than that. I guess that's what I'm saying. Yeah. So I think those are the kind of key points that I wanted to make today. If you want to think about very long-term storage, for sure, we should absolutely do this. It's completely critical and very important. And there's a lot of fundamental things we have to think about in terms of hardware prices and bandwidth and electricity. that go into determining this, and we can make a lot of progress on this, and we can make a lot of progress on the funding side as well. But I think there's still some way to go, but yeah, we're going in the right direction. So I'll finish it with that. Thank you.
Thanks a lot for that, Tom, for that nice reflection on the difficulties and the complexities inherent in modeling this sort of perpetual storage, these sorts of long-term questions. Speaking of long-term questions, do we have any questions to the speaker? Yes, one over here.
Thanks so much. That was super, super interesting. I'm curious. I mean, I think some of these things where you're like, oh, there's a ton of assumptions to consider and it's just like very hard to do. I think insurances do it, right? Like all the time, they like model very uncertain events, and then there's still some price that they set to determine that, you know, this is what I'm willing to accept as a price, and then sometimes they make wrong bets. I'm curious, and then Arweave exists, right? And they have, I think, articulated some price where they're like, you pay for the first 200 years with 30% of whatever you put down, and then the rest goes into an endowment that I guess is similar to what you're describing, that then yields some interest and assumes some price decline for other things. What's your take on how they're approaching the pricing? I know it's like a different model in that there's like only probabilistic guarantees for storage still being around, versus in Filecoin there's more deterministic, but just curious, like, right, like Arweave has kind of tried to address that and has come up with some kind of mechanism to price it. So curious what your take is there.
Yeah. So it's kind of an interesting question. I mean, I think there's two ways to think about this in general. I think there's the research aspect and looking into all of these details. And you can go into definitely a lot more detail than is in the Arweave paper, which is kind of a relatively simple model and makes quite hardcore assumptions. And trying to look into some of the sort of sub-problems and sub-details is what I'm doing here. And that's kind of more of a research question. And then there's kind of more of a business side, which is like, okay, we've got this idea, we're going to release it. There is going to be some risk associated with it. It might work, it might not. Yeah, so it's kind of like two sides. I don't know if that answers your question exactly, but that's kind of what I feel. You know, you can jump into doing it, but it's 100% not going to be guaranteed. There is going to be a little bit of risk associated with it. Yeah.
Right. So I think, you know, a lot of this, we're thinking having a proof of storage every day, right? But some of these older data, they really probably don't require that necessarily. So, you know, what are the requirements if you want to really put it in a glacier type storage environment, you know?
Yeah, so I mean, I guess that's kind of an interesting question that maybe touches on some of the kind of deeper protocol level aspects that we might want to think about in the future. So that, you know, currently we have proofs of storage that go every 24 hours. Maybe for very long term storage, that's not even something we necessarily have to have. You could have proofs that are only submitted once a week or something like that, which might change the cost as well. So, I mean, I think that kind of touches on quite an interesting idea for sure.
Well, thanks again, Tom, for a great talk and for giving us, again, that long-term perspective. Yeah. We'll move on now to our next speaker, who will be joining us virtually, Edward Shi. Edward's a data scientist at Starboard, where he's part of the network analytics team that designs products and pipelines to support network governance in the Filecoin ecosystem. He's passionate about geometry and number theory, but today he'll be talking to us about Filecoin analytics for network governance. Take it away, Edward.
Thank you for the introduction. Hello everyone, this is Edward from Starboard. Today I'm going to give a talk about Filecoin analytics for network governance. All right, so let me begin my talk by making a simple observation that Filecoin has actually become the most vibrant data economy in the Web3 space, with a committed storage capacity over 15 EIB and active amount of client storage deals over 70 PIB. Now, one of the key issues arising from being such a huge, complex adaptive system is that how do we properly govern right? Govern such a huge, complex adaptive system, especially with the case that, we're adopting a community-driven, democratized sort of governance framework here. So like there's, in some way, there's really a strong need for an accurate, comprehensive, and open source data analytics infrastructure upon which collective decision-making, real-time collective decision-making can be made. So in particular, right, we as a team, we've identified a few key challenges intrinsic not only to the Filecoin governance sort of framework, but also to Web3 governance in general. And we believe that, these common challenges for those, data analytics is precisely the key solution to addressing those challenges. So let me go through them one by one. Firstly, observe that each Web3 network is essentially an island economy that involves decision-making from individuals and organizations with essentially different preferences, goals, and horizons. Therefore, what this means for the governance team is that they really need to understand how to balance the trade-offs of different decisions, given that agents in the environment basically have different preferences, goals, and horizons. For instance, right, say the governance team wants to introduce a Filecoin improvement proposal, we commonly know as FIP, they need to have a very clear understanding, like whose benefits, whose expenses, how will this particular FIP introduction impact the sort of entire network, not only from aggregate, but also from actor specific level. Secondly, despite everything is publicly available on chain, public information is actually not properly diffused. This is a key problem. So if I ask you a question like, what is the current state of a network? What are some population statistics? What are some of the micro trends and issues existing in the network? We need expertise, or we need a middle layer to actually extract that kind of on-chain data insights from the blockchain architecture and make them available to the general public. Third key challenge / observation is that, governance doesn't have to be emotional and political. The key really is to have an accurate and robust data analytics upon which the community can make informed decisions for their shared goals and values. All right, so what I just talked about is basically establishing that network analytics is important for governance. But how do we proceed, right? How do we proceed, go from the first principles into actually building data pipelines / basically making the insights into product? Well, we start from the following two initial observations specific to the Filecoin, and we actually derive some systematic strategies from these two observations. Firstly, notice that similar to Web2 data solutions, Filecoin is a data economy consisting of a globally distributed network of servers and clients. This implies that like Web2 services like AWS or Azure, we need to track operational intelligences traditional to the Web2 data service provisions. Things like storage uptime, reliability metrics, which is also tied to the fantastic talk Tom just gave. We need those like metrics, right, to actually properly evaluate the effectiveness of the Web2, like actually the storage provision service. We also need a very clear KYC, things like, who are the top, addresses that are making the most interactions on the network. Now, on the other level, right, this is a second observation. Unlike Web2 solutions, Filecoin is the world's data center. What does that mean is that essentially it's a decentralized layer 1 protocol, right? Basically trying to democratize the entire storage provision, data centers, or data economy services to everybody, participants on the network. This means that we also need to track intelligence or intel specific to the blockchain analytics. Metrics like circulating supply, gas, block rewards, right? Those are the concepts or metrics, statistics basically native to the blockchain ecosystem that are not traditionally available in Web2 basically services. All right, so now we've actually moved on from the observations. Here's our roadmap, sort of derived from that two observations. So here's what we did, and we thought is a good roadmap for making everything happening. Firstly, we need to understand the Filecoin's protocol structure and basically build expertise in analyzing the state synchronized data, right? So basically we need to, call some RPCs and grab the data out, build databases. Next, we're going to map the on-chain data to the corresponding protocol features and design specifications, right? Those are available usually in the source code or open source. In the spec, we're going to map the on-chain data to different parts, specific features or protocol. Then we're going to translate the know-hows into actionable insights, charts of statistics that actually support decision-making for relevant stakeholders in the ecosystem. Last point is the most important, right? After we did the first 3 steps, we need to build a comprehensive data analytics platform that provides intelligence across different angles, across all the different fidelities. So with the principles and methods and roadmaps discussed above, very proudly we introduced the network health dashboard. So this is our flagship product that usually, basically try to analyze views, analyze the network's health state through different angles. All of the things I've just talked about, discussed the principles and methods, it's all in there. So the best way, we're actually trying to provide a section-based user journey, where through the different sections, we provide a very clear way on how we think the governance team should approach analyzing the current state of the network. And so the best way to summarize the product, this is a one-stop comprehensive intelligence platform that provides not only current, but also historical data analytics for the ecosystem, especially for the governance team. So let me just briefly give a tour, introduce each subsection and the information we capture. So we're looking right now at the first section, which is the capacity and service. This is the place where we track, information related to storage provision on the network. We ask questions like, for storage state, right? What is the active amount of storage currently existing in the network? How many sector commitment, storage capacity commitment has been sort of committed on a daily basis? We also track reliability indices, right? The stuff Tom just talked about, if there are faults happening, right? How quickly are those faults getting recovered? What is the average fault time distribution overall on an aggregate level for the network? We also track service provision economics, which tells us about, if I'm a storage provider, I want to, put a storage into this network, what is the rate of investment versus return? What are some of the current block rewards I'm going to get if not now I want to basically commit. So moving on, we have the next section, which is the circulating supply, right? This actually tells you about the token flow. How many fill, let's say, for example, gets mined, how many fill gets vested, how many fill gets locked or burned on a daily basis. And you can also do data drilling, right? That's the purpose of the entire the process. You can basically read about the component breakdowns for the aggregate statistics you find interesting. For instance, you can have a detailed look into the different components of fill locked, the amount of fill get burned. All of those detailed breakdowns are there according to the protocol specification. So moving on, we have storage demand and deals, right? This is the demand side of the equation. Here we track stuff like, what is the deal inflow? What is the deal outflow, current and historical? We also track stuff like, how do we do KYC? Even in a relatively anonymous environment, we want to identify the top addresses that are making the most deals within the ecosystem. Next is an exciting topic, network usage and gas. We track, what is the current base fee, and also tracing back to the past 24 hours, corresponding to the EIP, equivalent to the EIP 150.59. What is, we kind of see the base fee, right? We also want to understand, if there is let's say if there is a base fee spike, what is the gas usage that actually contributes, basically can be attributed to that particular base fee spike. So this is where we put things like gas usage breakdown by methods, telling you a volume comparison. We also try stuff like aggregation, right? Basically, aggregation is a scalability technology innovation the team has made, the Filecoin team has made for proof of storage. want to track, once this innovative, fantastic technology is out, how often are people actually using this, storage provider actually using this to reduce the amount of transaction cost. I've just talked about a little about the structure, the theory, the principles. Let me just give a particular use case on how sort of product like such can help with Web3 governance. So this is a real life use case. So in the past few months, starting January 2022, there has been various initiatives in the Filecoin ecosystem focusing on driving Filecoin Plus deals adoption and in basically increasing the network utility. For those of you who are not familiarized with the term, Filecoin Plus deals are deals with a better KYC and tighter identity verification. So let's just imagine that if I'm a business analyst and I'm asked to write a report on the initiatives, trying to drive out Filecoin Plus adoptions, but at the same time, I'm asked to basically quantify the impact of the various strategies developed to drive the adoption. Here's how I can use the dashboard. Next page. So the first place I'm going to go to when I wake up in the morning is I'll go to the storage deals section in the dashboard, and I'll observe that this chart called newly committed deals. This actually tells you, how many deals gets flow into the system on a daily basis. This actually tell me as a hypothetical analyst that over the last 3 months, Filecoin Plus deals has actually taken over majority of the deal growth. And you can see, by the green amount of green area presented in this chart, and is not actually Filecoin Plus deals now accounts for over 70% of all of the active storage deals outstanding. So, I'm a curious analyst, right? I don't just want to stop there. I want to go to the other different parts of a protocol and basically build a multi-dimensional analysis. So this is where I can go check into the storage provision section and see that, during the past month or so, we actually also see some spike in sector onboarding activities, which tells us, right, like there is a event correlating with a higher deal adoption is that actually more storage providers are thinking about, is either extending or joining the ecosystem to provide a more service provision coming in. Meanwhile, if I go into the gas and usage section and if I analyze closely the daily network fee breakdown, I will also realize that another thing correlating to higher deal adoption is that the network is actually getting busy again. Judging from the amount of fees activities, which is a direct indicator signal telling you how busy the network is. Next. So if say our analyst, right, is not satisfied with the overall statistics or trends and wants to do a more careful KYC, well, I can just then check the actor highlight and basically identify the top addresses that have the highest amount of participation. So here on the screen, we're seeing who are the top 10 clients classified by verified deal bytes, also who are the top providers actually actively taking Filecoin Plus deals. Okay, next. So if our analyst wants to further drill, right, wants really to get to the bottom of this, he or she can check basically the individual client page and identify the protocol-specific behavior and patterns. This is actually related to incentive design, right? What we're seeing here on the screen is a 3-stage, basically KYC funnel. This is called Filecoin Plus verification protocol, in which there is a notary who allocates, who sort of approves clients' initiatives to actually, verify storage deals in the system. So we thought about, how can we capture the transaction patterns in terms of graphic-based method. Graph-based method is a great way to basically concentrate our analysis on and basically build a local level transaction graph analysis for each of the client existing in the system. So if our analyst wants to dig further, that's where he or she can look. All right, open source insights. We're in Web3, all of the insights are supposed to be open source, right? Remember I talked about, not all of the public information are properly diffused. But now that we have done the middle layer work in between, we can just build open source these insights for everybody to participate in the ecosystem. So we're currently testing. We actually released a bunch where we have like very positive feedbacks from people from Masari. Basically, we're open sourcing insights in terms of data field notebooks and charts onto this platform called Observable HQ. So for everyone who wants to build their own analyses, they can just treat this as basically a doing analytics type of style of like API and just download the data, do their own analysis. So exciting opportunities. As I said, right, Filecoin is such a fantastic ecosystem. There are so many aspiring challenges, data science challenges, engineering challenges, like cryptography challenges we can do. But some of the stuff more related to my line of work is we have tons of visualization, modeling analyses, just as Tom just presented, right? There's tons of problem in terms of intelligent sector reliability profiling engineering. We have the data available and just about how we can build the best model of this. There's also questions related to computational game theory, incentive design evaluations, and evolutionary games. And also, I just give a quick snapshot on we can do a lot of transaction graph analysis on this sort of open public chain as well. So also stay tuned for Filecoin Virtual Machine, which I believe one of the next speakers will get into more closely. Thank you. Please, we're hiring, so you can visit us at our website and contact us. And I just, hope there are more people will join in collectively build a fantastic ecosystem. Thank you.
Wonderful. Thanks for that, Edward. For that really, this is very exciting opportunities for anybody who's interested in data science or data visualization. Definitely that last slide about exciting opportunities. Very true. We have time for questions to the speaker. Excellent.
So I love the dashboards that you guys set up. Can you talk a little bit about how people are using it already? Like, are you seeing some good responses? Are people engaging with it? Are they building on top of it? I'm just curious what kind of interest you're seeing from the community in these kinds of visualizations and insights.
Yes. Okay. So a couple of examples, right? Basically, we have seen basically people inside the ecosystem, right? Mainly the governance team. I actually know a few stakeholders on the governance side who check out dashboard on a daily basis, and there is a lot of stories how they begin first observing a couple of changes in the charts they find interesting, and that ends up in an ecosystem-wide discussion on what is the current thing. What is the top strategies the entire system should focus? So one example is we've actually through our dashboard, one of a few stakeholders has actually realized, while there's a lot of sector retirement or expiration kicking in starting January, and after they saw that particular signal change on the dashboard, they sort of very quickly responded to it and just start building more initiatives on Filecoin Plus deal adoption and also sector high onboarding rate. This is I think is a perfect example illustrating this. We also have external adoption, people outside ecosystems. For instance, Masari, when they write the first stage Filecoin analysis report, they were using our observable HQ API to build their own analyses. Yeah.
Any other questions? While you're thinking, then I have one actually about consumption patterns of your data. You mentioned that you have both current and historical data available for the Filecoin ecosystem. Do you have a sense of how long data stays fresh? Are people still making a lot of requests for data from near mainnet launch, or is it mostly clustered closer in time?
That's actually a fantastic question. Right now there's a year and a half, right, since the mainnet launch. And we've actually seen a request from stakeholders, let's keep everything historical. Now, as the ecosystem develops, right, as the network develops, there will be the amount of data size, right, plus duration is going to be a challenge for us. So we've actually been discussing internally how our engineers, we can, basically design a good UX experience for people. For instance, right, when you guys first arrive, you will see a 3 months or 6 months snapshot of the charts you'd like to see. But there also options on the UX side that supports, if you want to see the full historical, we can also show that. Yeah, but so far, given the short time frame, everybody's like, let's just do historical.
Great, thanks again, Edward. Any other questions to the speaker before we move on? Seeing none, then I'll thank Edward one more time for a great presentation and introduce, that's right, applause, our next two speakers. We have a tag team coming up. That's right, things are getting more and more exciting. Momentum is building. Jamshid Shorish and Andrew Clark. Dr. Shorish is CEO and founder of Shorish Research and a senior advisor to the Uberlink Corporation, a technology firm which developed Vozon, the virtual observatory for the study of online networks. He also works with the Australian National University's Vozon Lab, where Vozon is used for research tool development, teaching, and training. Andrew Clark is a data economist at Block Science with a background in financial and technology auditing, with a focus on building machine learning auditing systems. And together, they will present an empirical study of Filecoin gas and some ongoing research. I'll turn the mic over to Jamshid and Andrew.
Great, thank you very much for the introduction and welcome. Thank you for the invitation, also to ZX and Alex. It's a pleasure to be able to present some of the extant work that Block Science has been cooperating with and through the CryptoEcon Lab. My colleague Andrew should be online momentarily, but in the meantime, I will go ahead and just kind of give an overview of what it is that we're doing from the Block Science side of things and how it applies to two extant research directions that we're working on, one of them having to do with the gas dynamics of the Filecoin network, and the other one through a pass-through of a simulation framework that we have into an assessment of a particular type of protocol update around the batch fee and the batch balancer. So what we'll be looking at very quickly in our time available today is to start with a section on gas dynamics, where we'll be looking at the way in which data was surfaced, how that gas usage was decomposed into its pieces, and then extrapolate using that particular decomposition to understand and inform how it is that we can extrapolate forward gas usage given a particular time series of the network. That in itself is extremely useful for building out a simulation framework that actually goes on a macro level, step by step, through the Filecoin network and acts as a digital twin. A digital twin, which is built in the CAD/CAD simulation framework at Block Science, is one of the workhorses by which we can understand how, for example, different types of activities that may have occurred or different types of scenarios that we would like to know what might be happening can pass through the network and allow us to have actionable insights. Utilizing both the digital twin and the gas dynamics analysis, we'll then go into a very quick application area, which has to do specifically with the batch balancing system, where we'll look at kind of what batch balancing is in a very quick snapshot, and then kind of wrap up with extant research on utilizing the framework of the digital twin and the gas dynamic systems to move forward into actually selecting among a very large class of possible batch balancing frameworks, one which may meet the criteria that we would like to be most interested in for being able to assess when it is optimal to aggregate different messages and when it is optimal to keep them as separate messages. So that's kind of the overview of what we've got for moving forward. I'm checking to see now whether or not Andrew is available. I'll do a quick check here. Otherwise, I will jump in and take over a section. He's coming online now. Very good. Okay, Andrew, I'm going to give the floor over to you. I'll continue to drive just in the interest of time to make sure that we have ample time available for the rest of the talk.
Okay, that sounds good. Thank you. So what we started with was, it looks like it's between slides. Oh, perfect. We started with an exploratory data analysis around the gas mechanism to understand kind of what was driving gas usage and gas limit and some of the other things, and understand a lot of the key components that drive it. We did a lot of different methods and different aggregations. Do it on blocks, or do we did it by seconds, by days, and tried to see how the trends were happening, all of that kind of information to really understand what the key drivers were. So the types of analysis we did, if you go to the next slide, please, was also checking the change of actor methods. We created our own data dictionary based off of what the storage miner 5 means, for instance. So we went in through the Filecoin code and figured out what those things were, so we could see the percentage change in message counts, for instance, between different times. Like this right here is a week percentage change between a week of September 2nd, which is an example of this storage miner 7 had a massive increase in the number of messages over this course. And we did these types of analyses to really see what we're driving in combined with macroeconomic variables. We also use things such as Fourier transformation, which is on the right-hand side here, to disaggregate the data into a frequency domain and be able to see what the components were and see the trends. So we could start, and then we did phase shift analyses and things like this, all to try and understand what were the key drivers so we could understand the intuition for building predictive models off of the system. So as we're going to get into the digital twin and how that whole system works, we wanted to make sure that we could understand what the key signals were so we could derive specific models to be more predictive as we get into the system identification, which we'll get into in a little bit, for how we're forecasting states forward as the different actors are interacting and getting very accurate gas usage from the bottom-up approach. One of the main techniques we use, if you go to the next slide, please, was something called Granger causality, which is a very interesting method that we used to create our vector autoregression models. By what Granger causality does, this allows us to understand if certain variables from a VAR model, which is it's just an autoregression model with you determine the number of lags and you can have many different factors. What this heat map shows here on the right is we can determine, like at the top here, is base fee burn. Does that cause one of the actor methods to have a higher count? And what Granger causality does essentially is it's a way of trying to infer the causality of, does this variable cause this other variable based on the lag from a VAR model. So what you can see here is based off the p-values and the statistical relationships. The green are the variables. If you intersect from the column and row, you can see which variables have that factor. So what we were trying to do is, based on the time period we had, which is one of the key considerations we'll get into in a moment, based on, we were using the Sentinel Filecoin database, that is truncated at specific periods of time. So we didn't have a massive back history, especially if we're doing daily data for how these different method classes work. As most likely, as we're looking at like an operational digital twin to drive business insights, we kind of want daily values for these things. We had a dimensionality problem of having way too many different actors and their different gas usage. It was way too wide of data for the amount of rows we had. So that's a dimensionality issue where it has a very hard time training models. Traditionally, we would use something called a VAR max model, where it's the vector autoregression is the endogenous variables. What we're trying to predict would be the gas usage of these different actors methods. And then we pull in macroeconomic variables as the exogenous. In this case, the macroeconomics would be, base fee, burn, and some of these higher things. If we're trying to predict all the different signals from the Filecoin network, minor penalty, pledges, that kind of thing, anything that we think is relevant that we can derive here to be able to predict what this gas usage would be. So because we ran into this difficulty, and you can actually see on the left-hand side here some of our plots of the end model we ended up with. We're not going to go into all the specifics of how we have it. We have a little bit more information in the appendix, and we can definitely follow up offline. We use something called if you go to the next slide, please, a VAR-X model that Dr. Shorish came up with, which is essentially, by using this Granger causality, we can understand what the key macroeconomic variables were, and then we ran them as a normal VAR model instead of this normal VAR max model. And then this allowed us based on this analysis as well, we found what were the key drivers, because there's so many different actor method classes. We only need some of them to be doing Pareto principle for doing an accurate digital twin that's performant. And we can see here what the different gas usage per day from these different accounts. So we used this method that was faster, that got around the computational limitations, that allowed us to build this integrated digital twin that allows us to get the previous state and predict the next state from our operational DT. As we were building this out, you can go to the next slide. We started running, yeah, that works. We started running into issues as we're building into the digital twin. Issues with data, longitudinal data for back testing and things like that nature. and be able to really fully build a model, we needed a longer period of time of the data. And we were, with Sentinel, was truncating that data. As the operational digital twin, we want to perform health metrics, we want to inform decisions, we want to sanity check behavior, expect behavior. We need a long period of high fidelity data in order to do this. And this was the goal of all of that analysis we were building towards, was being able to make this gas dynamics for extrapolation digital twin that helps make decisions for the Filecoin network and helps doing parameterizations and things. And when we started really taking that initial analysis we did, which we knew we had limitations based on how far we could go back in the data, and then based on what the goals were here, if you go to the next slide, please, we created this operational digital twin infrastructure ourselves, where basically what we did here was we went back and got old Lily data fields. We got all these different data sources and Sentinel, because we lacked the fidelity and the longitudinal data that we needed for our analysis. So there is, Filecoin did also have an internal research database, but it didn't quite have the right fields and things as the different aggregation layers we're using, and all of the different signals we needed based on our EDA analysis of the different macroeconomic signals from our VARX analysis with that heat map that we showed. We had to build our own internal infrastructure, which is now up and running, that allows us to basically every night batch data from Sentinel. After we backfilled with Lily, we then can use Sentinel and then aggregate into our digital twin data fields and aggregations we need. So then when we have this operational digital twin that's used by Filecoin stakeholders, they're pulling directly the refined data fields from the block science RDS here. That's a lot more efficient than trying to ETL and do all of these analyses each time, because the code to ETL from the raw Sentinel production parsed messages, for instance, into the daily level or epoch level gas usage data that we needed is a long process and takes a long time to run. So we've now ETL'd all of that here, so we can have build this operational digital twin with the health metrics and the ability to do what if analysis and counterfactuals and parameterizations and have that into a solid state. So I'll hand over here back to Dr. Shorish for going forward on talking about how some of the gas dynamics then moved into the batch balancer.
Right. Thanks very much, Andrew. So what we're going to look at now is a very quick application of this digital twin infrastructure with the gas dynamics extrapolation exercise built into it, in order to understand one particular feature of the Filecoin protocol that has the potential for being updated. And so this is an active area of research we're currently working on actually building out the functional form representations that we're testing in the digital twin. Just as a quick overview of what the batch balancer is doing, what's happening in this particular environment is, as many of you know, that there is the opportunity for messages to be aggregated or batched in order to be able to save gas, and in particular for the largest gas usage messages of pre-commit and proof commit messages for the proof of replication. The intuition is that as the network use becomes high, then batching is incentivized in order to improve efficiency. And the mechanism by which this is being done, which is raised initially in FIP 13 and then updated once in FIP 24, is to have a batch fee surcharge with two different degrees of freedom, one of which is a batch balancer, which enables individuals to make a trade-off between what the base fee would be for a single message submission and what would be happening if you actually aggregated things together. And on the other side, a batch discount, which is a way of incentivizing a little bit of a shaving or a little bit of a haircut on that surcharge, depending upon how the system is performant. And in these two particular degrees of freedom, what we're going to see is that currently these are being set at once and then updated through governance. And what is being investigated is whether or not we can actually endogenize one or both of these to respond to network conditions. So just to give a very quick idea of what the Filecoin batch balancer would be set up to implement in this particular context, we would have a pool of messages that are coming in from storage onboarding as you want to have these sectors being sealed. They would come into a batch decision. The question of whether or not to aggregate then depends upon the state of the system at that time, the base fee that is available, and then what the batch balancing surcharge would be. Then there would be a decision on batching or not batching. If you do batch, then you get less gas per message, but then you have the batch surcharge, which is applied. If you do not batch, then you send messages singly. You have more gas than per message, but then no surcharge. And they lead to different types of outcomes on the stress, let's say, of the network. If you aggregate and batch things at once, then you're able to accumulate, you're able to use less gas and utilize less of the network, and there's a lower chance of network congestion. Whereas if you have individual messages that are singly being submitted, if there is already a high level of network utilization, then this will add to the burden to congest. And so the idea from the batch balancer is that if you have, for example, high network use, then what would be chosen in an environment where the parameters of that batch balancer are already being specified is to say, yes, I would prefer to batch in that situation, collect everything together to sort of use less gas and then lower the network pressure. So this is from the point of view of the network. What would we like to see? And of course, we want to ensure that there's an incentive underlying this for each of the storage providers to do so. By contrast, if it was in the low network utilization environment, we would say, well, it's not so interesting then to batch. Let's not incentivize batching as much. Let individuals use the network as in single messages, and then perhaps raise the network usage. And so we end up with kind of an equilibrating regulator system that's put into place, but it's predicated upon those 2 degrees of freedom that I mentioned, the batch balancer value and the batch discount. Now, how those are updated presently, well, those are updated by governance and by introducing a FIP. So as we move from FIP 13 to FIP 24, what's being introduced is a change to one or both of those parameters on the basis of what has been seen in between the 2 points at which these have been last updated. So you look over the interval and say, well, maybe it makes sense now that we increase the surcharge by a slight amount, or perhaps we decrease the discount by a certain amount. This is a way in which you can use expert knowledge to drive the update that occurs, but of course it means that you cannot respond in the immediacy of a change in network conditions, because you have to wait until you have an appropriate amount of time for review and the FIP to be accepted. So by contrast, the idea here is the active research we're looking at is to see whether or not we can put into place a functional form representation that explicitly depends upon the state of the network and that dynamically adjusts one or both of those parameters. And so if there is actually, say, high network utilization, that this dynamic batch balancer would then take that into consideration and then adjust in total that batch surcharge and influence the incentivization of individual storage providers accordingly. So by introducing a dynamic batch balancer framework, you, let's say, not necessarily eliminate the need for having governance, because you may want to change the form of that particular mechanism depending upon its performance, but it does mean that you don't have to change those parameters every single time through a governance process. The regulator system now has been endogenized. So the challenge, of course, is to create such a dynamic batch balancer that responds to network behavior autonomously while continuing to incentivize batching for the storage provider when network usage is high. And our current research agenda is to assess a parameterized dynamic batch balancer functional form within the digital twin, the operational digital twin of the Filecoin network that Andrew had introduced. The goals in that case then are to select, using the digital twin and understanding different scenarios, a parameterization that is informed by simulations that we engage and employ for various storage onboarding rates or various types of demand activities for Filecoin services. And that assists then in the recommendations for a FIP to implement the dynamic batch balancer upon conclusion of those simulations. These are simulations that are ongoing at the moment. And finally, the idea here for the batch balancing is to incorporate all of the information that we can about the existing network. That is to ensure that we understand not just the laws of motion about the system as a whole, but actually to understand what would the system like to have. So we know, for example, from a storage provider's point of view, they want to make a batching decision predicated on cost. But from the network as a whole, optimal batching is predicated upon network efficiency. There's a trade-off between the network becoming too congested on the one side and not having enough of the, let's say, protocol revenue of the gas being burned on the other. So the digital twin implementation allows us to model the entire network as a macro system that selects message batching in the simulated framework based upon network use and the gas usage from message traffic according to this batch balancer functional form. So we dovetail in the gas dynamics on the one side into the digital twin on the other, conditional upon this functional form, examine the scenario simulations that occur, and by using different metrics, assess which one or another parameter constellations are optimal for that particular implementation of the functional form of the batch balancer that we would be suggesting. So by the simulations, we actually look at various storage onboarding scenarios, high storage onboarding, low storage onboarding, high network congestion, low network congestion, to understand that impact of the different message traffic rates. And we combine those scenarios with the gas dynamics laws of motion that Andrew had uncovered in the first part of the talk to be able to run those simulations conditional upon as close to an understanding of how those gas dynamics are influencing things like the burn rates for different messages as possible. In order to be able to combine those two together, we then perform what is part of the engineering design work process, parameter selection under uncertainty to be able to figure out a range, usually, of parameter values for which the dynamic batch balancer can be then recommended. Okay, I think that's everything that we have the time available. I know we went through fast and furious for different research opportunities, but please, thank you for your attention. And naturally, if you want to have any more information, you can definitely contact Block Science and either of us individually. So thank you very much.
Great. Thanks to Jamshid and Andrew for a great illustration of the power of the digital twin model for modeling and simulation, and for a nice illustration of the relationship between empirical observation and mechanism design in the Filecoin ecosystem. We have time for a couple of questions to the speakers. I'll run up to you like Oprah. Don't be shy. Okay, I'll get it started then. I noticed in one slide you made reference to an intuition that you had about the system you were modeling when you were describing, when you're designing the batching mechanism. Where do these intuitions come from? Are there any real world or digital systems that you find are fruitful sources of intuition when you're building these kinds of models and when you're doing these kinds of studies?
That's a great question. So some of the kinds of environments that we look at are control systems. Whether or not we're looking at open loop or closed loop feedback systems, a feedback system which says that we would like to respond to a particular state of the system by taking an action that reinforces a criteria, such as stability or a minimal set of volatility. These become ways in which we can kind of understand the trade-offs that must exist for an individual of their own volition, completely of their own choice, to make decisions that affect the network as a whole in a positive fashion. And so it is, of course, a long-standing and open question about whether or not individuals, when doing their own thing, will do things such that they don't end up working against the community as a whole. So there is a lot of tension when you're trying to aggregate up from a micro decision to a macro decision. The idea within the context of the batching system is to say, we want to make sure that people understand that they can batch when it suits them at any time, but that we would see on the margin that they would decide to batch more often under conditions which benefit the network, for example, under conditions of high network congestion. There is actually an empirical fact that we have individuals who like to batch even when there's absolutely no network congestion. They batch a certain amount all the time, maybe thinking it's just simply an efficiency gain, even though they aren't necessarily earning any kind of savings from this because the network level is so low, the base fee is so low. This may call into question strategic issues of whether or not they are looking forward and saying, oh, maybe I'm actually going to change, perhaps my impact today changes the base fee in the future. And therefore, when I actually have my time tomorrow to actually engage in message traffic, I actually save money on that. And part of what we're investigating in this macro model is to actually model those types of strategic decisions, which are motivated from game theory, but are built into a macro model of the trade-off between the current benefit and the future benefit. So this is one of the ways in which we utilize that intuition behind driving the micro level to the macro level to build such systems.
Thank you for that. We have another question.
What kind of changes to the system would make it way easier to measure a lot of the things that you want to measure and make it easier to either run experiments or simulations and so on? I imagine a lot of this is sort of rate limited by the ability to do experiments or design different kinds of potential systems and so on. Are there any kind of changes that could come into the tech stack itself to make it easier?
Good question. I'll defer also to Andrew if he has an answer to this. From my side, it is the more information that you can get ex post about the distributions of things that occur in the system, the better. A lot of the challenge from the data side is to be able to build, let's say, a model of the distribution of the things that you're not totally under your control. So exogenous effects, for example, and the tighter bounds that you can place on that, so the greater the data fidelity is to be able to run some sort of a parametric or non-parametric estimation, the better off you are, because then you can close the error bounds a little bit over a wide range of different simulations that you might have. But let me also defer to Andrew if he wants to add something to that. It's a great question.
Yes, completely agree with what you just said. The other thing we are working on to make it so it is more accessible and easier to use for the analysis on the tech stack is moving it to Docker images, because setting this type of thing up is a lot of different dependencies and things. So one of the next steps that we have in the operational digital twin is like we have the data already set up in a specific way. We can keep making it so we can do the different distributions and as many pre-knowledge we have, but also the ability to then run this from a Docker container without the full setup allows us to crowdsource a little bit more some of the analysis, versus like if we're like, here's a repo with all of this code, it's going to take a long time to set that up, versus like if you have Docker, we can package all this so then you can go in and change params and do more experimentation. So from a tech stack perspective specifically, moving to the full digital twin to Docker will definitely aid the crowdsourcing of analysis.
Great, thanks. And do we have any other questions to the speakers? Aha.
I think in the architecture you showed like a lot of the data originated in a like Sentinel database on Redshift or something. Like what would be the trade-offs if you were sourcing that data from Filecoin or IPFS directly? Or would that help at all or hurt?
Mm-hmm. And that's the key thing is, so we also used a Lily, which is our S3 dumps of data from actual Filecoin chain. We used a lot of that as the basis of our backfilling as well. For the digital twin, a lot of times we're looking at a little bit more of an aggregated view than specifically from the chain. And internally at Block Science, we are looking at creating a system where we can basically ETL directly from different blockchains. So at that point, we could actually go from the Ethereum IPFS Filecoin system. But if we're doing operational DT for making decisions about how to structure the economics, going to that level of fidelity versus relying on like an aggregation that's even epoch level or daily or even second level, that kind of data is more what we need for operational DT. So at the moment, it's not going to create for the amount of additional work to hit directly from the Ethereum chain is not going to outweigh the costs because of where it's not going to create the benefit based on what the aggregated data we need. But definitely is something we're long-term looking towards. The closer we can get to the actual data and then have an aggregation layer, the better. And that's a long-term research project we're working on across all Block Science clients.
Great. Thanks again to Andrew and Jamshid for that presentation. And we're right on time to move on to our next speaker. Nicola Greco heads CryptoNet Lab at Protocol Labs, where he works to build technological empowerment through providing secure building blocks for Web3 technologies. Today, he'll be speaking to us about his work on the Filecoin Data Retrievability Consortium. Welcome, Nicola.
Hello, everyone. It's a pleasure to be here. I am actually representing Irene that was meant to give this presentation, but due to last-minute issues, she couldn't join. And this is most of Irene's work, and I'm here just to present this. Right. So the key topic of this presentation is how can we guarantee retrieval from decentralized storage networks? There are several storage networks like Filecoin, which do offer retrieval, but not a retrieval as a guarantee. And we will dive into this more. And it's very important that the retrievability of files from decentralized storage network must be web scale. So we can't just have a small decentralized storage network with a small amount of file that can be retrieved. Anything on the web should be able to be retrieved. And also, this allows not just the unbounded retrieval of storage, but unbounded onboarding of new of files in our network. We're going to cover 4 topics. and talk briefly about CryptoNet, and then about data availability and friends, data retrievability, the topic of this conversation, and then one of our proposals. If we work on data retrievability, it's because we believe it's important, but it doesn't mean that the other topics that we will look into, like data availability and proof of storage, are not important. We're also working on those. For context, CryptoNet is a cryptography applied research group where we do fundamental crypto research, vector commitment, snarks, and so on, but also protocol design. And our goal is to have our group of researchers to collaborate with several other researchers to grants or collaborations. And out of these collaborations, we will have new researchers, DAOs, new projects, and so on. Through time, we published several papers in the academic world related to proof of storage, consensus protocols, and so on. But also, we made substantial improvements to the Filecoin network. Some of the most notable were SnarkPack or SnapDeal. And one of the things that we also do is we gather a lot of ideas and start conversations on potential new protocol design. And all of our work is public. All the work that we do with other organizations is public. And you can see our CryptoNet notebook, which is where we post down ideas the moment they come to us. Some of these ideas, like the one that we're presenting, make into products as well. So let's talk in high level about data availability. The protocols of data availability can be divided in two steps. One is disperse and one is retrieve. The disperse protocol works more or less like this. The node that wants to distribute the data distributes to several nodes. Majority of the nodes approve that they have seen the data, and then the protocol can continue. If majority of the nodes don't give approval of the data being seen, then the protocol holds or wait until there is a disapproval. Why? Because it's very important for data availability protocols that data is distributed and that data had the chance to be distributed to enough nodes, such that when we want to retrieve, there is at least one of n in some protocols or m of n in other protocols, available nodes, honest nodes that are willing to serve the data. This is perfect for roll-up data or blockchain data, because this data doesn't have to be preserved for a long time. It can be pruned, and we need to make sure that at the moment of distribution, not only a few miners saw it, but as many nodes as possible. But there is some negative aspects of data availability as a theoretical problem. One is that it requires honesty assumption. The node will serve the data. There is, in most protocols, there is no guarantee that these nodes will be willing to serve the data later on. And the second problem is that it requires consensus on dispersal, which means that there's a limit of the throughput of new data that can be dispersed in a consensus protocol. Why? One of the core properties of a consensus protocol is that data gets distributed well enough so that everyone can verify that something has happened in the correct way. And in fact, most of these protocols aim at 1 to 4 megabytes per second, which is unfortunately not web scale if you want to do a storage network or guaranteeing retrieval. A reminder, retrieval is not guaranteed in these settings. Then there is another approach, which is the proof of storage approach, which is the one that we mostly use in Filecoin, and many other protocols use this as well. The idea is that the node distributes the data to as many nodes that they feel that they're willing to replicate the data to. This works in Filecoin. It's different for other protocols. And then from this moment onwards, storage providers generate a proof on a daily basis, in the case of Filecoin, to prove that they kept on storing the file. But even in this case, there is no strong cryptographic guarantee that the file will be served. The way we guarantee it in Filecoin, of course, is that there's always, we believe that if you distribute your file with several storage providers, or if you pick storage providers that have good reputation, then these storage providers will do a great job, and that's how that's how most protocols guarantee retrieval. And this guarantees onboard the throughput, because we don't have to have agreement or like a consensus on the fact that a file has been distributed. It's the role of the client to make sure that the storage providers have received the file. So data retrievability is trying to solve these two problems: unbounded onboarding and guaranteeing of retrieval, which doesn't rely on assumption of one of m nodes are honest. Also, most of these protocols are not really designed for providing retrieval long term. And while most of the previous, while data availability, it's great for solutions are great for rollups, they might not be great for, say, NFTs. Especially if we think that NFTs may be the standard for any digital asset, then 1 to 4 megabytes per second is not going to be enough. Plus, we don't want our data to be pruned in the future. We want to make sure that data can still be retrieved later on. So can we have a proof of delivery? So someone gives me a file and I have a proof that they can give me a file, otherwise I have a proof that they cannot give me a file. Well, we can't really have this without adding other assumptions. If we were other assumptions, so for example, there is a third party that checks that this exchange has been done, then that would be perfect. But without trusted party assumptions, then this is not possible. So let's look at some attempts on how we go around guaranteeing retrieval. One way, the naive way, is to use the blockchain as a witness. So if we assume that data in the blockchain is always going to be served by nodes in the network, then what we can do the following. We ask data to the storage provider. The storage provider doesn't give the data to us. We force them to post the data on chain. Now, clearly, we can post a hash on chain. We can't post 1 megabyte file. So this will never work for files that are, or data that is gigabytes big. So this technology, so storing data on chain, doesn't work for large data. The other alternative idea is proof of retrievability is a beautiful primitive that as you query the storage providers to give you proof of retrievability, they leak data. But it takes a very long time to leak a full file. So the idea would be to keep on querying the miners with proof of retrievability until they give you the full file. This works for small data. This doesn't work for large data. So the alternative is to have a trusted single party, but that wouldn't be ideal. And can we have a trusted third party that is decentralized? And this is pretty much the approach that other oracles take. So for example, Chainlink as a network of users that agree on the price that they see across exchanges for Bitcoin. And in a very similar way, we are proposing an oracle which says whether or not a file can be retrieved or not. And it works, in high level, it works like this. So the node asks for the retrieval to several storage providers. None of them gives them the file. And then the node goes to the oracle and says, I didn't receive the file. Go check if you can receive the file. The oracle goes and check. And if they don't receive the file, then they slash the storage provider, assuming that there is some collateral that the storage provider must put in order to participate in this protocol. If they receive the file, well, then the retrievability oracle has seen the file, and the retrievability oracle can serve the file back to the node. And this is in high level, one of the simple solutions that we're proposing. There are many big questions we will not cover in this conversation on how can we make an oracle that is a true truth-telling incentivized network. The MVP, which we will show at the end, is having the oracle as a network of referee, and the clients and provider agree on a retrievability deal. You can think of this almost as an insurance contract on retrieval of a file. When the client requests the file and it doesn't get it back, then it appeals to the referee or the oracle, the referee committee. Then we have a particular protocol where instead of querying the entire committee, we query a subset, even a single node, as a single committee node. They go and check if they can retrieve the file. If yes, they serve it back. If not, after K attempts of different referees, then the provider is penalized. This is the state machine of what I just discussed. Soon we're going to have a very nice diagram. but we're working towards a prototype that is going to show in the next few slides. There are other several steps in the protocol, which is the sign up. The provider must sign up. We have a sampling of the referee, which is follows a particular protocol, and then the retrieval deal. The goal of the retrieval deal is that it can be possible on chain. The beauty of this protocol is that it could be cross chain also. The appeal works very as I described before. And there are two retrieval steps. The retrieval step number one is that the leader doesn't get the file, and so if the leader doesn't get the file, then they propagate a message saying that they didn't get the file, and they go to the next step. If the leader sees the file, then they share the files to the rest of the committee, and the majority of the committee signs that they've seen the file. And that's how we keep posting the file on chain. We just sample a smaller network to check that the file has been is available and propagated, and it can be witnessed. If the oracle can receive the file, this means that the file was there from the storage provider and can then be propagated to the client. If there is enough, if there are K messages where the file was not well distributed, then the storage provider gets slashed. And you can think of this slashing almost like an insurance contract, where the retrievability deal, in the retrievability deal, the client puts a premium that the miner will get if they're always honest at the end of the period, and when the deal expires. And if the deal is still active and and the file is not being delivered to the client, then they get slashed. We have a prototype of this smart contract, and we deployed this smart contract 3 days ago, and it's live on Ethereum testnet, and you can create deals. And the way you can create deals, you can see what are the live deals. You can cancel, create them, withdraw funds from contracts, and there's a slashing process. And right now we have a small set of retrieval nodes that are part of the referee nodes that are part of the committee. And this is how it's going to look like. And this UX is just for the MVP. And anyone can put any IPFS CID in here. They can put what is the value of the deal, the premium, and then what is the duration of the deal. And so, for example, someone wants to make sure that they can retrieve the deal throughout the course of a month. And then you will be able to manage your deals. Deals are stored as NFTs, and so you can think of that you will be able to see NFTs in your wallet that shows which files you wanted to insure. The goals of this project is that we don't want to be a new network by any meaning. We want to be able to compose with every network. We want to give the ability for anyone that want to insure. We want to give the ability for anyone to insure IPFS files, and any node, not just Filecoin nodes, should be able to provide this service. Of course, we want to target Filecoin first. And although the smart contract has been deployed on Ethereum, as soon as we're going to have the FVM, this is going to be native in Filecoin as well. And another goal is that it must compose with other retrievability solutions that ourselves, Protocol Labs, and in CryptoNet in particular are also working on. And the goal is that there will be a set of smart contracts that other future providers can pack up and offer a single optimal retrievability solution. And we want to give flexibility on pricing, so clients and storage provider can choose the premium and the slashing. And then finally, we want to be web scale. We want to make sure that any file on any data on Filecoin can be insured, and also data from other storage providers. This is the QR code for the data retrievability Oracle project. As I said before, I'm just representing the project. This has been work from Luca and Irene at CryptoNet with the help from Sebastiano at Yomi Digital and Joanna from HUD. And you can join the conversations on the new Slack channel that we created, which is called Retrievability Oracle. And more broadly, there is a lot of work that we're working on CryptoNet, from snap research to vector commitments to threshold network and Filecoin improvement proposals. And we're always looking for great engineers to join our team, and in particular product managers that can take some of these ideas and turn them into products. So if you're interested in that, contact us. If you're working on similar solutions and you want to integrate with the Retrievability Oracle, but also with other projects that you're working on, feel free to reach out.
Excellent. Thank you, Nicola and Luca and Irene, for that interesting overview of your work on retrievability. Really exciting news about that prototype. Look forward to seeing it deployed on FVM, and for giving us some insight into your future goals about composability and scalability in the retrieval research. We have time for a few questions. And we've got one over here.
I'm just curious if what you would consider like prior art in this, or like what have you been inspired by on the retrieval, on this sort of retrieval insurance thing?
I think that so let me put it in this way. Since 2017, some of us have been thinking about these problems, and in the past 5 years, we looked into a lot of different things. I've been influenced personally by a lot of people that crossed through Protocol Labs, even in person in the company, but also at events like this. There has been several things that we didn't think that would work in the past, and then they got wide adoption. And then there's a protocol that is changing. I think they do Oracle really well. And what's very interesting about that is that the economics works out such that in order to fake the Oracle, so fake an Oracle outcome, you need to buy a large amount of tokens in chaining, and that's very expensive. And so the question is, it's a solved problem to do an Oracle for getting values of websites. It's very difficult to do an Oracle that retrieves storage from storage providers or even from IPFS nodes and then serves the data back. So that's a little bit more of an Oracle. And most of the I think Chainlink has inspired a lot of this in a way. And then also in other solutions that we have at Protocol Labs, that some that didn't make and some that are working in a different way. For example, Filecoin Saturn is a great example to look into. And this is just a different take on retrievability. And this is by no means the best way. This is one of the many, and it provides a specific service, which is insurance on retrieval.
Thanks. One more question.
Cheers. Thanks very much for the really good talk, Nicola. I was just going to ask you to expand a little bit more, if you wouldn't mind, about the insurance model and how you're thinking about the pricing and what kind of factors and how that's structured.
Yeah. So let me tell you, like some of our team are we're a team of researchers and not a team of economists. And so what we decided was that instead of writing inside the protocol, what would be a good price for insurance, we left it open. Or what is the token that needs to be used for insurance? We decided to leave it open to the market, and this gives, of course, a lot of flexibility. I'm sure in the MVP we're gonna pick some numbers. We're working with I think with some people from block science, trying to understand what would be a good value or good pricing mechanism. But there's one. So to answer you, I don't have a good answer on what would be a good price. There are too many factors to be taken into consideration, and there is still analysis that needs to be go through this. But there's one thing that is important, is that it doesn't mean that the storage provider is necessarily losing dollars or Filecoin. It could even be that the storage provider puts as collateral some reputation score. There's another project that Luca is going to present later on, which is called Storage Metrics DAO. And the idea is to collect metrics from the network. And these metrics are basically the reputation of a storage provider. And every time you're going to lose files, you're going to lose reputation score. So that's interesting for collateral. And in case we want to have under collateralized retrievability deals. Then on the premium, I think likewise, the premium, if it's a file that is very important, the client can put whatever premium to the miner as a reward.
Thanks again.
For those that are interested in doing pricing models for this is the best time to get into the Slack channel and get in contact with us.
Great. With that call to action, I think we'll thank the Data Retrievability Consortium one more time. And now it's time for everybody's favorite part of the event, a break. So please go down, enjoy the beautiful view, some coffee, some pastries, some juice, relax, and we'll reconvene at about 20 minutes past the hour for our next slate of talks. Hello and welcome back to the second portion of the program for the Filecoin CryptoEconomics Day here at Devconnect in sunny Amsterdam. Now it is my pleasure to introduce our next speaker, Patrick Woodhead. Patrick is the Technical Program Manager for the Retrieval Markets Initiative, which will of course be crucial to the further expansion of the Filecoin ecosystem. And he's going to talk to us today about, you guessed it, retrieval markets. Take it away, Patrick.
Thank you very much, Carola. Right, yeah. Today we'll be talking about retrieval markets. And as it's CryptoEcon Day, we'll have a particular focus on the cryptoeconomics of the retrieval market as well. Going to begin with some motivation. So, a statistic. By 2025, the global CDN market, that's Content Delivery Network market, is expected to be twice as large as the cloud object storage market. So cloud object storage, think AWS S3, CDN, you're thinking CloudFront, Cloudflare, Akamai. Now, when you first think about this, you might think, oh, that's actually remarkable. You store files in a classic traditional cloud, and then you kind of accelerate them as like an extra benefit. So why would it be such a bigger market? But actually, when you think about it some more, you realize the engineering involved and the hardware, the kind of points of presence around the world that are needed to create a great experience for everyone retrieving files to all of their browsers, their games consoles, etc. And they expect an amazing experience. They expect web pages to load instantly. That's a big engineering challenge, and because of that, companies are happy to pay a large amount to create such a good experience. So what I'm trying to say here really is that retrieval, now forget about storage. We've been talking about storage all day. Let's talk about retrieval for a bit, because it's pretty important. Okay, so what is a retrieval market? It's the name of the talk and the name of this team, but it's good just to try and get a definition sorted here. So for me, a retrieval market is a setting where anyone can come along and they can provide retrievals, file retrievals, to those who are demanding those files. So I'd say that those traditional cloud CDNs like Cloudflare, CloudFront, Akamai, they're working in a retrieval market. But we're looking here at decentralized CDNs, and in particular the Filecoin retrieval market. So Filecoin retrieval market, we want to enable a decentralized CDN or DCDN to emerge around the Filecoin network, so that we can have performant, reliable, economic retrievals of Filecoin data. So there's lots of different topics that contribute to creating a healthy and vibrant retrieval market. In the interest of time, I might not go through all of these particular building blocks right now, but we're going to focus instead on cryptoeconomics. Okay, so this diagram here is my attempt to draw up what's happening in what I call the primary retrieval market of Filecoin. So on the right-hand side in green, we've got the storage provider who's storing some content. And when a retrieval client over in blue on the left wants to retrieve a file from the storage provider, they have to do a few things. It's not as simple as just a browser making an HTTP request for a file. They have to set up a payment channel on the Filecoin ledger, and then they have to do what is called this optimistic fair exchange protocol, whereby the retrieval client will send, say, one voucher in exchange for 1 byte of the file, and then 2 vouchers in exchange for 2 bytes, because these two entities, they don't trust each other, and they have to build up this trusted relationship. And eventually, the retrieval client will send some vouchers over and will retrieve the last bytes of the file. The reason this is optimistic is because there's no sort of dispute mechanism. If the retrieval client doesn't get some bytes back for the vouchers it sent, it can't go and complain to anyone. It's just lost out on those vouchers, and that's why we build up trust. And eventually, the storage provider can redeem these vouchers that it's retrieved from or got from the retrieval client on the network. So the reason that we have to have this off-chain, well, when you set up a payment channel and then using vouchers instead of Filecoin, is because we have to have them really quickly. We don't want to have a blockchain transaction every time we want to retrieve a few bytes, and that's why this whole mechanism is in place. But it does mean that this retrieval client, there's lots of barriers to entry to being a retrieval client. You need to be able to talk to the Filecoin ledger, and you also need to be able to speak graph sync and do this exchange protocol. which means that the majority of clients around the world who want to retrieve files are sort of counted out from this. For a browser to do this, it's pretty difficult. So yeah, essentially the demand for all of these files is very difficult for that to match that to the supply in the storage providers. What's more, these storage providers are not really equipped to satisfy all this demand. They can take the odd retrieval, but they're not like a CDN where they can take kind of millions of requests a day. So this was how this primary retrieval market, this is how Filecoin launched. And what we're starting to see emerge now is what I've tried to capture in this diagram. So we'll start down in the bottom left. We have these content publishers. So you can think of, say, an NFT marketplace being a content publisher. And they want to accelerate their files and create a great experience for someone who's looking at NFT media, whether videos, images, etc. Now, they could go straight to the storage providers in green and create lots of deals to store that data. But what we're seeing happen is they actually speak to a deal, what I've called a deal and distribution service. And we could think of S3 as such an example. So they give the data they want to store to this deal and distribution service. And then this deal and distribution service can create deals with storage providers to store that data on Filecoin. And in the case of S3, I believe it's 6 replicas, or with 6 different storage providers. But then what we get is, and what S3 offer is IPFS retrievals. So it's saying, okay, you can store it on Filecoin, and then we'll make it available through an IPFS gateway, which is great. You've now got a retrieval story which is available to browsers and other usual devices that we use to fetch files. However, I think from a cryptoeconomic perspective and also a decentralization perspective, there's just a few things that we want to kind of improve in this diagram. So it'd be nice to see sort of a link between the storage side and the retrieval side. It feels like you're kind of putting something in the storage, into Filecoin storage, and it doesn't then speak to the retrieval part of the architecture. In terms of value flow, the content publishers will be paying to store stuff with Filecoin as part of a deal. The storage providers can earn block rewards for their storage. But in terms of this model here, IPFS is sort of run by whoever wants to run IPFS nodes or whoever's paying the bill for running an IPFS gateway. So that takes us on into the secondary retrieval market. So when I say secondary retrieval market, the primary one is retrieving from the storage providers, and the secondary one is where we can cache stuff outside of the storage providers, and we can start to retrieve between what we're going to call retrieval providers in blue. And the reason we've got a ring of them around the storage providers is just alluding to Saturn, which is going to be introduced later on, and the rings of Saturn. So it wasn't, I just got a bit carried away with copy and paste. So yeah, we've got some of the boxes from the previous slide. We've got the content publishers again, who are going to be giving content to the deal and distribution service, and they're going to be creating deals with the storage providers. But also, we can now connect the retrieval providers to the storage providers, and we can then enable some value flow between those two entities. And also, the deal and distribution service, rather than just making it accessible to the IPFS gateway, which they could also do, they can start to contact these retrieval providers and start to create the retrieval flow through these more decentralized offerings. So yeah, this means that we can have retrieval providers spun up by anyone, which is a requirement of this secondary retrieval market to be completely decentralized. The only requirement that we're adding back onto our clients is that they really need to verify what files are going to get back. If it's an IPFS gateway, you're sort of trusting that gateway to give you the right file. But if anyone can spin up a retrieval provider, then how can you trust they're going to give you back the right file? I might ask for a huge video and get returned like a tiny image, and that's not great. So there needs to be some way that I can kind of prove that the file that I've retrieved is right. And there we reach for content addressing, which is the answer for lots of things in the Filecoin network. And we can then verify that file. But browsers don't verify content address files very easily, so we have to add some extra mechanisms, perhaps in a browser, or whatever the client is, we're going to have to add that level of verification. And we can also then start to try and work on the properties which current cloud CDNs offer, such as traffic spikes and DDoS attacks, that sort of thing, and protect the storage providers from those internet scale phenomenons. And yeah, just much lower hardware costs to contribute to the Filecoin network. That's really important because we want it to be permissionless and decentralized, but if you have to own a data center to get involved, then it's not particularly decentralized. So we want to allow anyone to join who's just got some devices or spare devices which they could contribute to the network. So then we get to the question of how should a retrieval provider earn? We've got storage providers who can earn block rewards by doing proofs of storage, and they can also earn a small amount doing deals with people who want to store data. What I should mention here as well, though, is that the deals to store data can actually be negatively priced, which is a phenomenon only available in Web3, because the storage providers, they're so keen to get this Filecoin Plus subsidies that they just want to take valuable verified data. So they might even pay the deal and distribution service to say, give me good data. And perhaps that could then be used to pay for some of the retrieval providing. In general, though, we want to find a way that these retrieval providers can earn without, by linking it to the demand. Because if we just, let's say, one of the ideas we've looked at for how retrieval providers can earn is proving bandwidth. So you're just proving that you're online and you're up, and you can receive some sort of block rewards for proofs of bandwidth. But that doesn't, again, link retrieval providers to demand, to the number of retrievals that they're serving. And so we might end in a situation where people are optimizing to win these block rewards, again, for retrieval providing, but it's not linked to actually network demand. And so one of the questions that we're talking about a lot at the moment is whether your rewards as a retrieval provider, how dependent they should be on exactly how many retrievals you're serving. Because that's what we want to really promote in this network, is for them to serve as many retrievals as possible. And if we go back again to this diagram, if I'm not mistaken, I think the IPFS gateway run by Protocol Labs receives something like 1 billion requests a week or something in that order of magnitude. So there is demand for these content address files. So then, if we're doing it on how many retrievals a provider has served, at a network level, that's kind of makes sense. We can try and gather a list of retrievals made and then remunerate each retrieval provider based on that. But the issue then becomes that that's sort of centralized again. So retrieval providers, should they be then paid for each individual retrieval in a sort of a localized way to keep things decentralized? But again, then we're putting requirements onto the clients who are retrieving stuff from the retrieval providers to actually be able to pay for it as a sort of pay-as-you-go approach. So there's lots of trade-offs that we're facing with these retrieval providers to try and link them up to the usual clients that people use, such as browsers, but also be able to live in a completely decentralized context and earn rewards appropriate to what service they're providing. So yeah, we're seeing a bunch of different retrieval networks emerge in this retrieval market, which I've tried to crudely put on this Web 2 to Web 3 axis. And that sort of involves all these trade-offs that we've been talking about. So on the one hand, we have IPFS Gateway and the recently released NFT.storage gateway, which they're aiming to really compete with those Web 2 offerings in terms of performance and reliability, but giving up on verification or content addressable nature of the data. And then moving across to the far right-hand side, the Web 3 side, we have some more purists in this decentralized CDN space who are trying to reinvent the way that we retrieve data. And one I want to talk about in particular is Saturn. We've actually got the team building Saturn here today, who do a much better job than I would at introducing it. So yeah, Filecoin Saturn is exactly that. It's a decentralized CDN for Filecoin. At the moment, the way that it's structured is we have gateway nodes and station nodes forming two rings of Saturn around the center of gravity of data in the Filecoin network. The gateway nodes, they are in order for browsers to be able to communicate with this retrieval network, and as such, they have to have a slightly more centralized touch where we're kind of certifying them such that browsers can talk to them, and also requiring that they have very high bandwidth and high availability requirements. But we've also got this notion of a station node. And a station node is going to be a desktop app so that anyone can download this app and start contributing to the network. And Saturn is currently testing in V0. And yes, just to mention, now on Tuesday, we have a retrieval markets workshop, which is an introduction to Filecoin Saturn. So if anyone's interested in peer-to-peer networking, some of the web browser protocols like WebRTC, that sort of thing, some of the crypto economic ideas I talked about already, or just Web3 CDNs in general, then I'll be sharing some links to this later, or just come find me and come get involved on Tuesday if you're still around. And I think I'm probably out of time. Okay, well, I just put this in just in case there was a bit of time. And a lot of our time in retrieval markets and with the Saturn team, we spend discussing these trade-offs and what the real benefits are of this Web3 CDN compared to Web2 CDN. And I think for me, if I were just to pick one thing out of the slide, I think what's really powerful, and it's something actually which Tom mentioned in his talk earlier, it's about creating a more symmetric network rather than asymmetric network. It means that rather than it being client-server, I'm retrieving a file from Cloudflare, etc. Instead, I can retrieve a file from other peers in the network, and then I can even earn. I think that is an innovation which you don't get in the Web2 space, that users can retrieve and then earn for sharing that file with others in the network and act as a much more symmetric node in a distributed network. And I will stop there. Yeah, thanks. Any questions?
Excellent. Thank you, Patrick. He started off by saying, forget about storage. Let's talk about retrieval, echoing Eminem, forget about Dre. Bold words from bold men. Questions to the bold man in front of you.
Does the hierarchical consensus mechanism that's currently being researched at Protocol Labs have anything to do with the Saturn project, or is there any thought of like integrating the two, or maybe it's too early along to say?
That's a great question, and I'd say that I'm just going to be honest, we haven't thought about it yet. I haven't been in touch with them, but it's a great idea. What we have thought about is how we could use, once FVM launches, sort of layer 2 solutions to then, because there's been so many retrievals. It's like, how do we govern all of these retrievals? So like roll-ups, that sort of thing, enter the picture. So yeah, lots of ideas about how we can start to manage the sheer number of retrievals we hope to serve.
I noticed that you had on like the spectrum of Web 2 to Web 3, MyL or MiL network farthest right. Can you explain why that is and whether it's desirable for Saturn to be further to the right than anything else?
Yeah, sure. I mean, I don't want to speak for the MyL guys, but I think the reason I put them further along the axis is because they feel that it should be, each transaction should be paid for in that, it just be a local transaction between the client and the person who's serving the retrieval, and not be governed more centrally. And so if we want to transact, no one else is involved. I'll be paying you for a retrieval and you'll be giving me a file, kind of similar to the primary retrieval market. But that puts a lot of constraints on what clients can operate, because it makes it very difficult for browsers in their current setup to be able to communicate like that. So in order for a browser to operate as it does now, you have to have a few concessions to more centralized approaches. And I would say that the Saturn team, that's exactly what we've gone for. We've said, okay, we're just going to concede on these few things for now, and hopefully we're going to tweak it and make it more decentralized, more Web3 as we build. But we've just got to use the browser as it is now and try not to change it, because that could be quite hard.
Excellent. Thanks again to Patrick. I think we have time now to introduce our next. No, we do not. We have. All right. Well, then time for a little bit of interim patter. One question to get to know CryptoEcon Lab a little bit better that I've been asking the members of the CryptoEcon Lab is, what is your favorite karaoke song? We had some very interesting responses that you may not have expected. from Axel, who presented earlier, Dancing Queen by ABBA. So that's a goodie. I'd say that's pretty classic. Maybe a surprising choice from Alex, the TPM of the lab, Hit 'Em Up by Tupac. I'd like to point out, yes, there we go. Pride, pride, pride. New member, Vic, over here. He's a Michael Jackson fan. Billie Jean. I don't know if he can hit the high notes, but I know he can moonwalk. All right. Stay tuned. Maybe at the next break, I'll share a little bit about ZX. I asked him the question. He has not responded yet. And we'll make something up about Tom, who keeps dancing around the issue. I'm going to assign him Shipbuilding by Elvis Costello if he doesn't come up with something better. And now, let's see, do we have our next speaker lined up yet? Calling for halftime. Next speaker not online. So we may actually call on Vic to moonwalk. So I guess we're all here in the room. Many of us are, members of CryptoEcon Lab. Are there any, we could ask for general questions. Any questions you've thought about from presentations earlier in the day? And maybe somebody from the lab can attempt. My default will be to go to Tom or, there we go, another one.
Yeah, so Saturn has you want to, for CDN, you want to prove
labs working on onboarding data at scale onto the Filecoin network. He is focused on getting public data sets onboarded to the network via the Slingshot programs and is also part of the Filecoin Plus governance team, working on client onboarding and trust. Reach out to him at any time to chat about DataCap, DAOs, and some excellent puns. Today, Deep will lead us through Filecoin Plus and Data DAOs. Welcome.
Thank you. I hope everybody's doing well. Sorry I couldn't make it there in person, but it looks like a fantastic event and really well set up. So yeah, please have a blast today and celebrate a little bit extra for kicking ass and getting together and doing productive things in my stead as well. Thanks for the excellent intro. I'll probably just skip this slide in the interest of time. Just covering, leaving this up mostly for the parts at the bottom, where if you need to get a hold of me, find me on Filecoin Slack as Deep Kapoor, or find me on Twitter, Deep K Kapoor. Happy to chat about any of the things that I'm going to be discussing in this presentation, or anything at large with regards to large-scale onboarding of data onto the Filecoin network. So what I want to cover today with you in the short 20 minutes that we have is, number one, Filecoin Plus. For those of you that are unfamiliar with it, we'll go over the overall sort of core concepts of the program, how it works, how the pieces sort of fit together. We'll talk through Slingshot and the various Slingshot-related programs that exist today. And at the end, touch a little bit about how these things sort of are moving towards the direction of DAOhood or DAOification, with regards to sort of a larger scale understanding of what it actually means to do that, and then how you can get involved in what's next. So without any further delay, let's talk about Filecoin Plus. So Filecoin Plus, by definition, aims to add a layer of social trust to the Filecoin network to incentivize useful storage. What does that actually mean? Great question. So I'm going to say a bunch of things here, and I don't expect you to understand all of them, but then we're going to dig into each of the components, and then hopefully it'll start to make sense. So the first thing I want to tell you is that in the world of Filecoin Plus, we have these different stakeholders. You can see them in colored boxes over here. I don't know if this screen is big enough for you to see this in person, and so I'm just going to walk you through it because the text might be a little small. So you have community governance, root key holders, notaries, clients, storage providers, and miners. So the idea is that root key holders, notaries, clients, storage providers interact through the allocation and spending of a resource called DataCap. Effectively, notaries serve as a key stakeholder position. We'll dig into each of these by allocating DataCap to clients. Clients spend that DataCap in storing deals on the network. So specifically, clients who are data owners who are bringing data to the Filecoin network use it to make deals. And this will start to make very soon. But then in making those deals, storage providers who receive deals that are sort of coming in with DataCap receive a boost to their adjusted power on the network. And so you're at a CryptoEcon conference. It's important for us to explain to you what that actually means. The way Filecoin distributes its rewards is based on power. And if you're taking deals that have DataCap in them, then you're getting a 10x boost to the relative power, the relative footprint that you're occupying on the network with regards to that deal that you're taking on. So if you're taking a 32 gigabyte deal or gigabyte deal in this case, it looks like 320 and inflates the rewards that the network is giving you. So in essence, this is a network-based subsidy of deal making between data owners and storage providers. Now let's dig into what each of these different stakeholders are, define DataCap, and sort of help this all make sense and why it's interesting. First things first, what is actually DataCap? It's a novel generated resource within the Filecoin network. It's programmatically generated. We'll talk about how that actually happens. But as I just mentioned, clients and data owners use DataCap to make storage deals. It's a one-time use credit. So it's consumed as it is used in those deals. And then the storage providers receive a 10x quality adjustment to the power for serving deals that have been made with DataCap. So back to the sort of core stakeholders of Filecoin Plus and sort of defining them a little bit so you understand how they all come together. First, we talk about the root key holders. Root key holders are executors for decisions made by the community on the blockchain network. So they're representatives of reputable organizations that are in like our ecosystem effectively. Filecoin, IPFS, Web3 sort of spaces. But ultimately, what they actually are. They're signers on a multisig, and that multisig has the power to invent data cap and issue it to notaries, and notaries being other addresses on the network, which are then flagged with the identity of a verifier. So just to recap, community figures out who the notaries are, and we'll talk about that in a second. Root key holders are the ones responsible for executing those decisions on behalf of the community. This typically means assigning the value of data cap to a notary that they can allocate, as well as the status of being a notary on the network. Notaries are arguably the most important stakeholder that keeps this engine going. Their role is to do KYC and due diligence on incoming data owners and clients to the network. The goal is for them to identify trustworthy clients. So this goes back to the top line sort of definition of Phil Plus, which is that it's a social trust system, right? And so notaries are the ones that are actually looking to establish that trust, to figure out who the clients are that are worthy of receiving this data cap that will give them these extremely free or cheap storage deals. And so the idea here is notaries spend whatever effort they need to ensure that they build a relationship with the client, understand who they are, and give them data cap commensurate with the level of trust that is warranted based on the information that is provided by the client about what they're working on, who's funding it, why they're doing it, what their goals are, what the long-term plan is, etc. They also have a set of operational guidelines, which includes how they should do these things, toolings that needs to be used, need to keep a record, bookkeeping for auditing purposes, and ensure that they can actually talk through past decisions that they made and be held accountable by the community. They're selected through an election process, which includes putting an application out in the public, which is scored on a rubric. So that rubric is also open source. And the idea there is the community can iterate on the rubric. Notaries is scored against the rubric. We do a pretty open election process where a notary applies, is scored on a rubric, gets to sort of contest. And then the community also gets to contest. And then we finalize the rubric scores, rank all the notaries by their rubric scores, and then pick a set as defined by what the goals of that election process are. So hopefully this is starting to make sense. We elect notaries as a community. Root key holders give that particular address on chain the ability to do these special things like issue data cap to clients. And so clients, these are the actual data owners, the demand side of the storage marketplace. They're aiming to be and come across as trustworthy so that they can get this resource to make extremely cheap deals. Storage providers represent the supply side, as you can tell by now. And then last and certainly not least is the actual governance community. This includes, of course, all the above stakeholders, but also includes just anybody interested in the community. Our governance processes are completely open. We use GitHub as our primary tool for making progress on the program, indexing, documenting, and then we do open governance calls bi-weekly. And so literally anybody could participate, includes you, and come to our calls and help with things like defining the rubric, defining the roles, changing, adjusting the roles, putting in FIPS to adjust the way the program works, et cetera, et cetera. Quick recap on the flow again. So notaries perform due diligence or KYC on clients to verify them. So you often hear the term verify, but really it's just establish trust. The real client, they're looking for real clients with valid data that would actually bolster the usefulness or productivity of the Filecoin network, further its goals in like being the marketplace and storage interaction point for all of humanity's information, and ensure that the subsidy that's being created cryptoeconomically on the network is actually being utilized in the best way possible for long term, whether that's for the actual clients and their ability to do things because, the nonprofit organizations, scientific organizations, et cetera, or if it's for the network in terms of, hey, this is a really compelling use case that we want to serve, and we're excited in making sure that we're able to deliver this for everybody and show them that this can be done on Filecoin. It may also include stretching the network to understand how to handle. So we've got a working group, for example, that just spun up. They specifically think about enterprise support in Filecoin Plus. So how do we deal with data sets that can't be open all the way or are encrypted or have some private components? How do we still build trust with clients? Because traditionally, sometimes, notaries would just ask clients for samples of the data, but that's not necessarily possible in this world. And then based on the identification of clients and the reception of or allocation of data cap, they then go expend that in deals. As they burn that data cap, storage providers get adjusted power increases and get better rewards from the Filecoin chain. as long as that deal is live and that sector is running, et cetera, et cetera. Clients have three paths to getting data cap today. They can go in through automatic verification. A good example of this is the site verify.glyph.io. For anybody with a GitHub account greater than a year, greater than 6 months old, I think it's 180 days, yeah. You can pretty much get 32 GB every month. We're adding a scaling component for this as well, based on like how you're using it and how frequently you're asking for it to ensure that you continue getting more if needed. This is extremely useful for testing purposes. Like if you're just wanting to get your first deal or get your first 20, 30 deals, see how it actually works, like build up a system, do a mini POC for yourself. This is the recommended path. If you're a client who has a single use case and not a massive data set and is just looking forward to getting this done with the least amount of effort and the least amount of operational overhead, you opt for the second path, where you typically get between 10 and 50 terabytes of data cap. That's through working directly with an elected notary. All of this happens in public. All of this happens in GitHub issues. But this does have the option of, oh, like, can I email you this stuff instead? And then you maintain that in your books instead. And so it has a little bit more flexibility for clients. And then the third, and by far currently the most popular option, is to go via this, what we call the large data set notary path, or like the Filecoin Plus for large data sets program. And here the goal is you're requesting 500 terabytes plus for data cap. Each application can be up to 5 terabytes, but it's released in tranches as opposed to that data cap going out on its own. Completely public process, much larger, accessible amount of data cap. But because it's released in tranches, there's a little bit more scrutiny. Every tranche that's released requires some participation from notaries, etc. So where are we at with the program today? So on the right, you can see this graph. This is the last 3 months of active deals in petabytes on the network. The light green portion on top is Filecoin Plus. The bluish portion at the bottom is like regular deals. You can see that Filecoin Plus has really been on a tear since the new year. The LDN process has resulted in a lot of clients getting data cap and onboarding tons of data at a much faster rate than they were before. We're currently at the point where about 75% of all the data stored on chain is actually verified data coming into Filecoin Plus. That means more than 55 petabytes of data cap being used in deals. And that represents about 75% of the data cap that's been given to clients. And so there's still about 25% that's sitting latent, and every single day more data cap is being issued and distributed. In terms of notaries, we just wrapped our third election closing. And so we're at about 60 active notaries soon, once they're all onboarded and willing to participate. Last year, we spent half of it at about 10 and half of it at about 20. And so we're 3xing the amount of notaries in the program, and also like significantly increasing the amount of data cap available to them to serve. And this is mostly an experiment to see how the program actually scales. Right now, if you go and work with a notary, it takes about 10 days to allocate data cap. So it's very important to us that we work towards bringing that number down. So upcoming focus areas, well, actually, these are more like current focus areas and upcoming development. First is what I just mentioned, what we call TTD. That stands for time to data cap. This is like our top line sort of success metric in the Filecoin Plus program. We want to ensure the data cap is available and attainable in like the 1 hour to 3 day range at all of these levels. And so that includes, having more notaries, having the notaries be more active, improving the UX for clients, automation and scaling for data cap applications, et cetera. You can see the little flow chart on the right, which sort of walks you through how we want to move towards more automation, reduce manual interaction points, and only bring in the human interaction in the cases where things are starting to go awry. Focus on risk, reducing the amount of touch points, more focused on sort of on-chain tracking and automation of like flags for like risky behavior or abuse or profiteering of the program. Like, we're thinking about this as like us building out a reputation system or a credit system for data owners and storage providers inside the Filecoin Plus world. And then generally evolving the notary role a little bit to go from what we call like the gatekeeper-esque functionality to more like guardians of the network. That changes the way in which they interact, but of course comes with discussions around their incentives, how to retain their attentiveness, and overall have them deliver a service effectively to the network while still maintaining the best interests of the network and not themselves, and participate in governance in addition to just what the community does today. So how do you want to get involved? We'd love to have you come join us in the Filecoin Plus channel in Slack. We have bi-weekly governance calls. You should come there. We're working on sort of improving our processes, We'd love to have you think about notary incentives, think about how we want to evolve processes and system design, and generally as we move towards like structures that are similar to like a DAO, we're spinning out working groups, experimenting with governance, system design, etc., and generally overhauling the incentive and long-term ideation around how Filecoin Plus will continue to serve the network into the future. And we're having a Filecoin Plus half-day summit at Austin, Texas, the day before Phil Austin, if you haven't heard of it yet. So Phil Austin will happen June 8th. We're doing Filecoin Plus Day June 7th. This will be a virtual first event, so even if you can't make it in person, we'll be broadcasting this, live streaming it, and of course recording it. So definitely more information to follow on that. Keep your eyes out. Switching gears for the last couple of minutes here to talk about Slingshot. Slingshot is a community program for data processors and developers that rewards the storage of real, valuable, and usable data on the Filecoin network. So this is completely different than Filecoin Plus, but you'll see some similar threads, and sort of in closing, hopefully, I'll be able to share with you why I'm talking about both these programs and why they're compelling for you. So Slingshot overall has been running since Filecoin went mainnet, which is just about 18 months to the day. Through these 18 months, we've had about 37-ish petabytes of data onboarded to the network, comprising of open data sets. So there's like 61 data sets, all the way from like COVID data to environmental data to governmental data, and like random public use things that we've found that could be interesting, sourced from scientific organizations, nonprofits, NGOs, etc. We also have a data explorer, which is pretty compelling in terms of helping you identify where you can retrieve that data from its mirror on Filecoin, as opposed to needing to pay for an AWS retrieval service or needing to run your compute operations in different cloud provided services. Here, you can actually get it effectively for free or extremely cheaply from the Filecoin network itself. Recently, in the last 6 months, sort of to couple with just this onboarding thing, we've added 2 different programs as well that are focused on the longevity and the long-term viability of the data being onboarded. So on the left, you have Evergreen. The idea with Evergreen is effectively, as Slingshot deals reach their end of life, we want to continue renewing them. So right now, this is a little bit more manual. We're very excited for the Filecoin virtual machine to show up so that we can automate some of these things. But the idea here is tracking the pieces of data that are in expiring deals, and then incentivizing the rebuilding of replicas for them to ensure longevity, permanence, long-term availability of that open data on the Filecoin network. The primary driving incentive here is actually data cap. And so this goes back to the first part of the conversation about how are we able to do this? The idea is that by adhering to an extremely high standard of quality storage and showing that we're getting to do things that push the definition of how to make data useful on Filecoin, how to contribute to best practices around that, both for the data owner side of the house, but also for the storage provider side of the house, we're able to justify to the notaries that they should sort of support the running of this program. On the right, we have recovery as an effort, and within recovery, specifically the Restore program. Restore program specifically started out around an incident where we lost a little bit of data, well, a substantive amount of data after like a freak accident, effectively a fire in a data center. And so we built this as like the first step towards like self-healing, where we can design systems where data on Slingshot, if it's lost, and this is specifically not in terms of end of life for deals, but rather like a sector like faults or a search provider decides to walk away, how do we rebuild and self-heal from that? Like, how do we maintain a healthy number of live replicas at any given point in time? How do we make sure they're available? Both of these programs are currently open, and Evergreen, especially if you are thinking about a storage providing operation and listening to this, it's a pretty interesting one to get started. Definitely check it out. Why I'm telling you about this. Quick primer on DAOs. I think you guys are all aware of this. Decentralized autonomous organizations, typically referred to as a combination of community plus some sort of contract. What we care about, or what I care about right now, is specifically DAOs that care about data. So the creation of value through shared data or data sets. This is not just limited to the monetization of demand for data, though that is one excellent use case and one way in which data DAOs have often been described, and arguably the data DAO sort of set that ideation process forward with that scope. So what I'm trying to structure right now is like using these components together. It's a very complicated flowchart on the right. I'm not going to dig into it too much here, but the idea is that we've got a component we've got a set of components that come together very nicely to build a system that can, in a clean manner, set up data for long-term preservation on the Filecoin network. So with just Slingshot, you've got onboarding data. With Evergreen, you've got the aspect of guaranteeing its permanence. With Restore, you can do the self-healing and the rebuilding. And then we have this component that we've used in Slingshot for a while via the deal bot, where we check for retrieval success rates. So we've got retrieval success rates as a service, as I like to call it, where we do sampling and retrievability and have metrics on the health of the data itself. So even though it might be alive and the deal might be good, that doesn't actually mean that it's accessible. And so by having a path to onboard, maintain, ensure that it's repaired, and have a way in which it's like all those things happen in a way that like clients that need to access that data are able to, we do have all these nice components that sort of come together and can leverage like significant automation and development in the future to build like an interesting DAO structure. And so we'd love to have you involved if you're interested in this conversation. Lots of work to do ahead of us here, definitely in terms of defining the incentives, the governance, et cetera, leveraging the virtual machine itself. Of course, also just the data architecture and how we want to do the analysis, how we want to like build that sort of reputation aspect that I mentioned. So specifically, if you'd be interested in thinking about these things further, please reach out to me either on Slack or Twitter, or this QR code should actually take you straight to our definition and JD for one of the roles on the team. That doesn't have to be the role you want. I just wanted to put it up there as like a, hey, if you want to get involved sooner, definitely please check that out. Awesome. I know I'm a little bit behind schedule. Thank you all for bearing with me and getting on my speed train as we were nearing the time limit for this presentation. Thank you for having me, Alex and ZX, and congrats once again on the event. I'm looking forward to being there in person next time. In case there's any questions, please feel free to chase me down. I don't know if we have ability to do the questions right now because I know there's a pretty packed agenda to keep you guys going. But I'm going to rely on the host to let me know. If not, really appreciate your attention.
Thanks a lot, Deep, for that overview of Filecoin Plus and Slingshot and their various aspects. We have time for maybe one question to the presenter.
Hi, yeah, just really quick. So I understand storage miners will want to participate in verified deals to, have an increased percentage of the block rewards. What is the incentive for clients to want to get, notarized or verified to have more data cap?
Yeah, great question. So because storage providers have that incentive, the amount of actual fill or like money that gets charged to make those deals is significantly lower. Actually, the average verified deal in the network today is completely free. So the incentive for that KYC and due diligence process is effectively you're trading that time, that effort, that loss of complete privacy on what you're doing and adding a little bit more transparency for getting absurdly subsidized deal making on the network. So especially as storage providers start to build long-term businesses on the network and want to offer the ability to store data at scale safely, instead of having to pay and fill, you get to effectively extend that data cap and spend it. And so that's why it's extremely interesting and compelling for clients to go through that process. Of course, we are working on making that process easier and faster and all of that. And so that is also good, hopefully, for clients in the long term, but that is the primary incentive today. I'd say there's a secondary social incentive as well, where like doing this stuff in public means that everybody in the network sort of sees that you're trying to do the right thing, sees the work that you're putting in behind it, helps you sort of gain clout for long-term partnerships, long-term relationships, hopefully favorable deal-making climates in the future. But then, coming into Filecoin Plus Day, for example, we have a couple of people on both sides of the marketplace that want to be presenting, share the work that they've done, the tooling they've done, and how they're contributing to the success of the network. So I'd say, yeah, the monetary incentive of an extremely cheap deal, the social incentive of building cloud in the network.
Thanks for that, Deep. And with that, I think we'll move on to our next presentation. We're pleased to welcome Sylvan Zhang. Sylvan is Product and Operations Lead at Starboard, working on various product research and development projects in the areas of network governance, Web3 service marketplaces, and creative user engagement. Today, Sylvan will be charting a course through new frontiers in Web3 with Filecoin EVM. Welcome, Sylvan.
Hi. How's everyone doing? Can you guys see my screen?
We can now, yes.
Cool. Yeah, hello everyone. Hope that all of you guys are doing well and enjoying your time in Amsterdam. My name is Sylvan and I work at Starboard on products and also operations. I'm really honored to be here, although not physically, but hope you guys can feel my spirits. So today I will be talking about like why Filecoin is an important building block of Web3. And then also like what new opportunities will be unlocked when you combine the provable storage of Filecoin with the programmability of EVM. So before we get started, let me just quickly introduce Starboard a little bit, who we are, what we do, and what are our goals. So basically, we are a main contributor to the Filecoin ecosystem, focusing on network analytics and also application design. And the reason we're doing this is that we found the Filecoin network to be highly sophisticated, right? I mean, it's sophisticated enough for 11 speakers to talk straight on various topics without any repetition. And but this level of sophistication brings many challenges to the ecosystem and also to all its participants, like storage providers, clients, investors, in terms of understanding Filecoin and also participating in this unique Web3 data economy. And that's why we aim to provide analytic solutions and also product development to drive network understanding and adoptions. And for the analytics part, I think my colleague Edward has had a great talk this afternoon. And basically, our approach is to build data analytic infrastructures and to help people understand what's happening. And for the product part, we're trying to build like intuitive products to help people use the Filecoin blockchain, whether it's making search deals, calculating service economics, or participating in a creative data storage experience. So we have been working in the Filecoin ecosystem for quite some time. And what did we find? First, Filecoin is enormous. It has around 16 exabytes of storage capacity available. To put that into perspectives, if the recording of my talk, of this talk is 16 exabytes, it means that this talk will last about 3.8 million years. But I mean, it's okay. I promise I won't keep you guys that long. And also there are around like 72 petabytes of real data stored on Filecoin from over 3 million storage deals. And according to the stats from NFT.storage, there are over 58.2 million NFT objects stored on Filecoin. And in terms of assets, and this is the part that people usually didn't pay too much attention to, in terms of assets, there are currently 130 million Filecoin locked with the network, which is equivalent to around 2.6 billion in total, $2.6 billion in total value locked. And also, Filecoin has one of the most vibrant developer ecosystem in Web3. I mean, there are fabulous teams working on all kinds of use cases, all kinds of infrastructures, tooling, and also like different programs. And so far, many has considered Filecoin as the storage layer for Web3. And the current major use cases include providing storage to NFTs and also Web3 use cases. Providing storage to like Web3 to Web2 data sets, or like providing permanent storage, and also to a metaverse, gaming, audio, and video. However, we think that this is just the beginning. When smart contract programmability are combined with provable storage on Filecoin, there are a lot of value and potential to be unlocked. So think of the storage and retrieval capabilities on Filecoin as the layer 0. And it's already a super valuable stack to Web3, but it's insufficient for developers who want to build more complex applications through programmable smart contracts. And now let's go to the layer 1 of the smart contract programmability, which is the key to the success of Ethereum. And currently, Filecoin does not have this kind of user-defined smart contracts. So in order to access programmability, developers use bridges to other programmable blockchains. I mean, I've presented a few, like for example, like Ethereum and also Near are some of the more like commonly used blockchains for programmabilities on Filecoin. The Filecoin team is working very hard to bring general programmability to Filecoin, and there have been tremendous progress with the development of the Filecoin virtual machine, or the FVM. So the FVM is a WASM-based polyglot execution environment. It's designed to support both native Filecoin actors retaining languages that compile to WASM, and also foreign runtimes such as EVM. So it means that Filecoin will bring together smart contracts and also provable storage on one network. I'm just like so excited to talk about what opportunities that FVM will unlock. So So a very obvious opportunity will be in the NFT space. I would like to share an article I read a while ago. This author makes a joke about the current NFT structure, where the storage of the NFT metadata is not verifiable. So it's pretty funny. It's like really funny thought experiment, but consider that billions of dollars of NFTs are actually traded every day. I think maybe it's worth some attention. And a great opportunity is to create NFTs with verifiable metadata. And it's enabled by decentralized storage and also smart contracts. So, I mean, you will never find a strange looking emoji in your wallet after spending significant money on an NFT. And another thing that FVM can enable is like content first NFT. So it's actually quite bizarre to me that people don't actually care about the content of the NFT, but we believe that there's like tremendous value in the content as well going forward. So just want to briefly mention NFT storage. It's a wonderful tool for people to store their NFT with like Filecoin. And then we're pretty sure that with the programmability and also like capability of the FVM, there will be even more like use cases and more popular use cases with the powerful provable storage on Filecoin. And so earlier I mentioned that there are actually a lot of people often ignore that there are just so much assets that was committed to the Filecoin network. So, which I think that another opportunity that lies ahead is DeFi with Filecoin. And as previously mentioned, there are over 130 million Filecoin locked with the network. And if we are comparing to some of the DeFi projects, a $2.6 billion TVL will actually rank Filecoin 8th among all DeFi projects. And what's more important is that according to our data, we found that there are actually over 1 million file in demand for token collateral every week. And also the annualized on-chain field-to-field return can be as high as like 90%, which I think is a great opportunity for a staking protocol that can leverage this fantastic high field-on-field return, and then generates like a really attractive yield over those on the other blockchain networks, which are normally on like low double digits, like 15%, 20%, right? And another opportunity is data DAOs. I feel like many of the speakers have already addressed on this topic. So I just want to like bring some different perspectives as well. So we often hear people saying that data is the most important and also the most valuable assets in the 21st century. So creating a DAO around data assets I would say it seems like very reasonable. And like from my perspective, I think there are generally three kinds of value in data. One is the value in evidence and record. The second is in the value in information. And also the third is the value in derived insights from like, for example, like machine learning or computation over data, etc. So there could be like various forms of data DAOs holding that data assets that generate different values. For example, on the evidence and records, we can have like data DAOs that aim to preserve records for the internet, or maybe just making sure a meme will last forever, like for centuries, right? That would be pretty cool. And for the value in information, like a pay-per-view, a pay-per-download a business model can work well with like articles, movies, and music, right? Think of a DAO that hosts the rights to like some articles, to some movies, and then you have this kind of like a pay-per-view or pay-per-download mechanism. All right, this DAO can run itself as well, right? Because it is generating value. And also like for derived insights, user can pay to compute over data asset owned by a data DAO, right? This can be a very common use case for machine learning and also like deep learning. So I just want to bring like bring out an example. Is the Ocean protocol. I think it's not on FEM, but it is a data market on top of that leverage the storage of Filecoin. And basically what they do is to create, they create and also use data tokens to publish and also consume data services, right? So this can be a very good examples for some of the data DAOs explorations or like data market, data asset marketplace explorations for FEM. And also just to add on like what Deep just introduced, about Filecoin Plus, which is a great incentive program to useful storage on Filecoin. And it gives storage providers 10x block rewards and can significantly improve their service economics. So with the help of FEM and also like Filecoin Plus, we can actually create a store to earn experience to encourage users to store useful data on Filecoin and have storage providers bid to store them. Right. So it actually makes a lot of sense because by adopting the Filecoin Plus program, the storage providers will have like a higher ROI, a higher storage returns, and then they are more than willing to actually take a share of that to bid for more volumes of data caps or more volumes of like useful storage. And this actually also creates incentives for clients to migrate their data or to actually store their data with Filecoin. So this actually can be a very unique use case and also like a unique experience for Filecoin, as it can never happen with like Web2 storage providers. And there are many more ideas and opportunities that will be enabled by FEM, including perpetual storage, reputation metrics, storage bounties, retrieval markets, and so on. And for the interest of time, I will just provide some context, but not discuss them in details. So what is Starboard doing, or what is Starboard exploring with FEM? We're actually exploring a few different use cases that can potentially leverage the capabilities that FEM brings. For example, we're trying to explore the store to earn experience. The slide I showed earlier on the right, this is actually a product exploration from the Starboard team. So basically, we're trying to build a auction style platform for people to actually put their valuable or like put their useful data on this platform for storage provider to bid to store them, right? So this is like a prototype of a store to earn experience. And if FEM comes online, a lot of that logic can happen on-chain with the programmability of smart contracts. And also another thing, because we believe like we are like working a lot with data analytics, and there will definitely be a lot of new metrics and a lot of new data fields that we can analyze and then provide insights on them. So we in one area we're also working on as FEM data analytics. Reputation metrics. This is also very important. We have a reputation dashboard for Filecoin storage providers that provides context for when people want to, for example, make a lending deal to a miner, to a storage provider, or making a storage deal to a storage provider. Right? You need a lot of context. It's just like you are making a deal with like a Airbnb host, and then you want to see their track records. And also we're exploring like DeFi lending, right? So that could be a very interesting use case as well. And we're also hiring. We're hiring smart contract engineers, blockchain engineers, data scientists, researchers, product managers. So if you're interested in riding along this amazing journey, please feel free to reach out to us. We can also discuss more opportunities that FEM will bring as well. All right, that concludes my presentation. I hope you like it. I hope I have provided some useful information. Thank you.
Great. Thanks, Sylvan, for that data-based view into the possibilities inherent in the Filecoin network. We have time for a few questions to Sylvan. A lot of data. I know you have to take time to come up with a good. Well then, seeing none, we've got a little bit of time before our next speaker is slated to begin. I'll give a thanks again to Sylvan, and please make sure to check out those opportunities that he mentioned. Just to make sure that we don't get too far ahead of schedule for the people who are running, who are viewing virtually, I will mention that I did get a response from ZX on what his go-to karaoke song is. It is Bohemian Rhapsody. That describes the scale of his ambition there. 4-part harmony. It's not for the faint of heart. And if I get the go-ahead from technical in the back, I think we can introduce our next speaker. Yeah, we don't. That's the problem. This is why nobody hires MCs from Germany. We tend to run fast. But Luca is here. Luca Nazzardo, I'm pleased to welcome. He is a cryptography researcher in Protocol Lab's CryptoNet Lab, where his research interests include vector commitments, contingent payments, and zero-knowledge proof systems. And today he will be speaking to us about storage metric style. Welcome, Luca.
Hey, thanks for having me. It's a pleasure to give this talk. Thanks for the introduction. I hope you can hear me well. I'm a researcher in the CryptoNet lab that, as you know, since Nicola gave a presentation a few hours ago, it's an applied cryptography working group inside the Protocol Labs. And in particular, in the last few months, I have been working on protocol opportunities, which is basically a working group that is working towards improving protocols for Web3. And this presentation is about one of the projects that we have been working on in the last few months, and it's about storage metrics for retrieval incentives. So the main question that we want to answer here is how to incentivize high quality of service. So we know that Filecoin already takes care of file being stored in the network. But if I am a client and I want to basically put my data in Filecoin, I also want to be sure that when I want my data back, the data is going to be back in my hands. And so just to, a question that we could ask ourselves is, who should I store my file with? Like, how do I pick my storage providers? And this project tries to answer this question, and we will see where we are moving towards, and how can we get there. So the goals that we have in this project are, first, having some on-chain metrics for storage providers that are realistic and objective, and that are on-chain. If we have this kind of metrics, then we can use them to reward storage providers accordingly. Not only that, we want that storage providers optimize toward these metrics because it's rational for them to do so. So it's going to be convenient for them to give high quality of service because our protocol will make it possible. We will put in place a reward system that we aim to build as interoperable with others, right? Everyone can build some reward system on top of ours and make it work with ours, improve it, like refine it, and basically do whatever we want. And not only that, we are not focusing only on Filecoin specifically, but we think that our our metrics DAO could be also useful in many other applications in Web3. For example, there are like other applications that are computing over data that could profit by having some sort of metrics DAO on top of it in order to make reputation systems for service providers, not only storage ones. So what's the long-term plan? We want, of course, this metric network to be decentralized, like no central authority involved. Open, meaning that both on the auditor side and on the service provider, storage provider side, it should be incentivized in order to be sustainable on both sides, and it should be resistant to auditor collusions. Like, we do not really want auditors to kind of, be allowed to set up a cartel and influence these metrics in one way or another. In essence, what we are targeting is like having honest reporting as the best strategy for auditors. And this is, as we will see in what follows, not so trivial to achieve. How do we get there? So we imagine a network of auditors that scan a network according to some metrics that we identified and that we can update on the way whenever we think that it's the right moment. There is also an incentive to report through metrics, and that's, in order to make, as I was saying before, honest reporting as the rational strategy. We also need to have a system to aggregate metrics on chain, because it's not feasible that, as long as the auditor set scales, everyone posts his own result on chain. And of course, there is also an incentive for storage providers that provide good service, because if not, there is no point in all of this. So which are the metrics that we identified? For now, we identified 3 basic metrics about retrieval that are time to first byte, average retrieval speed, and retrieval success rate. But we are open in the future to introduce more metrics to be taken into account. And of course, this protocol would like to be, aims to be metric agnostic, in a sense that you can plug in the metrics that you want and make it work. So what's the overview of the protocol that we have in mind? Talking at high level, we imagine a committee of auditors that query, ideally, each storage provider individually. The second step is auditors taking part to a survey, which basically is, you can think of it as like answering some questions about storage providers' performances. The individual surveys are then aggregated. An aggregated result is extracted and posted on chain, and then both storage providers and auditors are rewarded for providing good service. On the storage provider side, this will have to do with the metrics that they got in the aggregated results, and with the auditors, that would be according to the accuracy of the metrics that they provided to the auditor network. So of course we cannot get everything in one shot, and we have identified 4 milestones to make this project happen. The first milestone is the milestone we are actually in today, and it's the initial consortium one. So the first thought on our side was there are a lot of people and a lot of entities that are already scanning the Filecoin network for their own purposes, for building a reputation system based maybe not on retrieval, but on other parameters. And so we basically have an ongoing open call for partners that are interested in joining forces with us, with the aim of building this auditing consortium. Of course, at this stage, even if the data that each entity has is kind of partial, they do not really scan the entire network, they do not test retrieval on all the storage providers. At this particular stage, it's fine. We think that it's better to start and to refine everything on the way. And the result of this first stage would be to have an on-chain reputation system for storage services based on the observation of this initial consortium. We envision this initial consortium to be kind of small, like 5 to 10 entities working together as a sort of auditing league. And querying storage providers of Filecoin for technical reasons. The second milestone is to open to anyone to join the storage metrics DAO as a retrieval provider. So basically, in the second phase, we are not focusing only on Filecoin storage providers, but ideally anyone, for instance, an IPFS node, can become a retrieval provider being audited by the network. And we can get there by, for example, using some project that Protocol Labs is developing internally, like indices, where people are basically publishing a list of files, of deals that they are willing to provide on request. The third milestone is actually introducing incentives for storage providers and retrieval providers. And that would be like where actually we are testing our protocol in the real life, like seeing how the storage providers are reacting to our auditing services. And the fourth milestone would be, of course, creating a reward program for auditors, and that will need like cryptoeconomics insights, and also allow anyone to become an auditor. So we are basically passing through from a phase where we have a few entities that kind of are already working on Filecoin metrics to some extent, or on storage metrics to some extent, to open it to anybody that can join as an auditor. In order to make the auditor league going at scale. So now, which are the very next question that we need to answer in order to advance? The first one is how to structure the final survey protocol. And basically, the main issue that we have, I mean, that everyone that is working on such topics have, is supporting collusion. So we started this journey by investigating some Bayesian truth serum-like mechanisms, which are used usually in psychology in order to test behavior of people. And we thought at the beginning that could be, something that we could apply in practice because, these mechanisms are rewarding unexpected results. So we were thinking that maybe this could basically force people to say unexpected truth and to find unexpected behaviors of storage providers. But unfortunately, I mean, either internally and also collaborating with external researchers, we figured out that such tools were not designed to support collusion. And so they're not kind of applicable to scenarios where there are entities that are communicating daily together and they can exchange or they can have interest in exchanging information. So the main focus is making collusion irrational for the auditors, or at least detectable, and in general, making honest reporting being the best strategy. The second question that we have is, should we anonymize auditors or making them indistinguishable from generic clients? Why do I say that? So the key question that we want to answer is, the key point that we want to answer is, we want these metrics to be reliable. And in order to be reliable, basically, we should avoid storage providers to behave in a different way when they're talking with an auditor and when they're talking with, let's say, clients that are not auditors. So here we have two options. The first option is more, let's say, protocol heavy, which is the protocol by himself anonymizes the auditors. And the second option is auditors actually is in their interest to put in place mechanisms for which they can spot such behavior from the storage providers. And basically at this stage, we can reevaluate in the future maybe, but at this stage we are leaning towards option 2. And the reason is that it's of interest of anybody that these metrics are accurate. And so auditors can actually either cooperate themselves, they cooperate with like clients, they can set up multiple identities in order to make this detection more difficult. But we think that, you know, the system is like self-governing itself at some point. The second thing, the other thing that one can argue is like most of the metrics that we want to measure depend or are influenced by proximity. And again, we have different options on the table. We can brainstorm about that if anyone has ideas. But one option could be like divide storage providers in clusters depending on the location, or like auditors having multiple nodes in different locations, and that's something that some organizations already have for other purposes. The thing that I want to stress is like all this project works well for everybody, and especially for auditors if the measures are accurate. And so it's on auditors' interest to make the measures as accurate as possible, because this will maximize their reward. So how can you get updates on this project? We are working in the open. You can go to the Notion page of this project, and you can find all the updates that happen over time. The team is composed by myself, and you find me on Filecoin Slack on the under Luca. It's composed by Irene and Nicola. And then we have also external research collaborators focused more on game theory from the Aarhus University, and we have internal engineering support by the Bedrock team. Thank you, and let me know if you have any questions.
Thanks, Luca. Any questions to Luca? Storage metrics down.
You kind of touched on this with the voting protocol, but I guess, are there any other ideas you all have for making sure the auditors don't collude?
So that's a really good question, and that's something that we are actually, you know, actively working on. There are different countermeasures. These protocols are basically divided in two steps, which are like voting rules and rewarding rule and payment rule, where payment is like the reward that the auditors are getting. And so one intuition that we have is like, if you have, for example, a per round fixed reward, and this is like actually your payment rule, this would like not encourage you to share your observation with others. Why? Because basically, if you are confident that your observation is accurate, sharing your knowledge with other people would, in the long term, lower down your per round reward. Of course, this is only an intuition for now, but we are kind of confident that we can put this in place. And the other thing on the voting rules are like there are results that add some sort of redundancy and randomness in the voting algorithm that could help making collusion ineffective somehow. We will post news on the website, but I mean, feel free to reach out if you want to know more. This is something that we are particularly working with our external collaborators on game theory. So I would be much than happy to keep talking about that.
Thanks. We have time for a few more.
Is there any prior art that exists in other projects, either other decentralized projects, or like you said, research in other areas that would have to deal with auditors and service providers not colluding?
So, kind of surprisingly, to the best of my knowledge, it's not that common to have people studying such kind of protocols. And indeed, we try to get around some limitation of the BTS protocol. And actually, after talking with many people, which is not our primary area of expertise, so we had to basically ask other experts. It's kind of an unexplored land, and we really think that in the Web3 setting, it would be, an interesting research direction to pursue. And we are actually, trying to understand if like a long-term research plan on this is something that maybe we can get into in the future. But it's not, the thing is like, long story short is like, all the work that has been done in doing this kind of surveys did not take into account collusion, because basically people were not really interested in getting other people's opinion. One classic example is like, you are in a department store and people tell you, do you like more, you know, this book or this other book, and you want to basically build a survey on that. For this kind of situation, there are, you know, BTS-like mechanisms that work pretty well and force people to tell the truth. But if you think about this for a second, you are not really interested in what other people are liking. Like you are happy with what you like. Well, instead here, and when you basically put incentives on top, and when you basically enter in systems like blockchain, where people, you know, communicate and exchange information all the time, it's much more difficult to come up with something that is kind of effective.
We have time for a couple more questions. Any other questions to Luca? If not, then I have one. There was a mention, you mentioned the auditor system. Their identities, they want to work on sort of a secret shopper model with the storage providers maybe, so there might be some identity obfuscation there. Can you walk me through again, who knows who the auditors are? Who's holding that kind of information?
I mean, that's exactly the point. There are two options here. There is the option where nobody knows who the auditor are, especially when they run the survey. Like maybe you know that there is some organization who is an auditor, who is auditing the network, but you don't know like under which identity is auditing the network. But you know, you can always backtrack and do this kind of thing. So either you enforce this by protocol, but this, you know, adds some sort of complexity burden to the whole protocol, or you basically play under the assumption that since being undetectable and having, you know, reliable metrics is uninterested of all the auditors, then the auditors themselves would put in place their own countermeasures, which can mean, you know, making deals with like clients, which would mean like having different clusters that that query different storage providers and so on and so forth. And for now, we are basically leaning towards the second option.
Wow, thanks again, Luca, for walking us through that very complex system and the system design. I think our next presentation is actually occurring in person. Are we ready to go? Any of you? Okay, otherwise I have to moonwalk. Come on up. Excellent. We'll take a 5-minute break and then reconvene. All right, welcome back, everybody. Our next and final speaker needs no introduction, but I'm paid per introduction, so he gets one anyway. Juan Benet is the founder of Protocol Labs, the research, development, and deployment lab which developed IPFS and Filecoin. He's committed to building a better future using science and technology, and today he's going to round out CryptoEconomics Day, Filecoin CryptoEconomics Day, with a talk about solving large-scale problems with Filecoin.
Hey everyone, great to be here with you. Awesome day today. So what I want to talk about is how we can use CryptoEcon and Filecoin to solve massive scale problems. Certainly over the last 10 years, it was already getting this sense, but I think really accelerated over the last 3 to 4 years. I've come to see the stuff that's happening with Web3 in terms of incentive design and mechanism design as the largest levers that humanity has right now to fix massive scale problems because they enable this kind of incremental growth of some solution in a way that other microsystems have not quite enabled. Really awesome day and great to dive into the depths of Filecoin CryptoEcon. This last talk is gonna go more broadly into thinking about how we can use these CryptoEcon principles to shift other large-scale systems, and how we can use the facilities of Filecoin itself to do that kind of thing. I gave a talk yesterday at Shelling Point called Achieving Paradotopia with Cryptoeconomics, which is kind of a prerequisite. So if you weren't there, bummer. However, I'll summarize it for you. The basic summary of the talk is there on the right, which is if regen, WACME, else, and GMI. The point is, if we can create regenerative cryptoeconomics, we're all going to make it and we're going to avert disaster. Otherwise, we're not. This is an extremely critical century. Though there's been this amazing range of global improvement throughout history, we are confronted with certain existential risks where we now have both the ability to wipe out ourselves and all of life, probably not all of life, but most of life, and we might screw up this massive computing phase transition that's happening. And unfortunately, right now, our macro systems are inadequate, though they've been excellent to get us through the last few centuries of global improvement. Maybe debatable whether excellent is the right word, but really good. We've just had this unprecedented amount of global improvement. However, we're headed into these kinds of problems that those government systems are not quite equipped to solve. Now, what we want to get to is kind of this Paradotopia outlook where we can use mechanism design to get everyone to be thinking in massive positive sum ways, where you're not thinking through small resource increases, but you're thinking of order of magnitude level increases. And you're getting people to stop negative competition and engage in collaborative competition or just straight up collaboration. Ideally, you want to create an environment where you use incentive structures to warp the actions that various different groups might take so that you align them towards this collaboration and you can get to the Paradotopian outlook. Paradotopia is this conception that once you kind of realize that the future is so amazingly positive sum, if you can get there, then it sort of makes sense for everyone to sort of band together, align on that cooperation to do the science and technology diffusion that we need to get to that fantastic future. So think of cryptoeconomics as this like tool that we can use to kind of reshape the landscape, whether it's by kind of like boring through the hole, creating a new hole through like this incentive field to try and get to like a better optimum, or by like moving mountains in that landscape itself. You can use mechanisms and drop them into the network to achieve this kind of thing. Just to give you a sense of, I think everybody here is already paged into how powerful mechanism design is, but it's just every year I need to kind of like step back and remind myself that Web3 is really programmable. The tooling that Web3 gives us enables us to really reshape any kind of coordination structure, and that's extremely fundamental. It's eating law, it's eating finance, it's eating all kinds of structures. And so we're going to be seeing over the next 5 to 10 years and beyond this kind of mechanism design rippling through major parts of the economy and major parts of governments and so on. So it's an extremely powerful lever. Let's make sure that we use it for really good things. So for example, in the Bitcoin hash rate has been incredibly illustrative to me over the years in showing just how powerful of a lever this mechanism design is. One straightforward incentive structure both enabled the world to get into the world of cryptocurrencies and actually enable the cryptocurrency to grow, to compete with fiat currencies. But it also, that same incentive structure also created a massive run of equilibrium that just wasted an enormous amount of energy. And there's taken what, 12 years or so? It's in 12 years we went from a network that didn't do anything to now one of the largest energy consuming things on the planet, which is wild. And that's kind of without the massive. That's also having to bust through the walls of getting people to accept cryptocurrencies and get into that idea and forming the entire Web3 movement in its wake. Now that the Web3 movement is here, you could redo something like this in probably 2 to 5 years. With Filecoin, we've gotten a taste of just how powerful these incentive structures are by creating an open and permissionless network. In a year and a half, we've assembled 15, 16 exabytes of capacity. That's an insane amount of storage. So that should give you a sense of just how powerful these levers are. Now you have to design it really carefully, and it's great that we are having this day to talk about the nitty-gritty details of these structures. But the main takeaway here is the more you can think in that kind of scale, the more you can make open and permissionless networks, and you design the incentive structures carefully to achieve good results, the better it will be. And also be careful, to take the Bitcoin story as a warning sign of the incentive structures you make once they grow to massive scales might have a bunch of unintended consequences. And so think through that. Now I think that we can use all of this incentive structure mechanism design to accelerate the science or technology translation process itself. A lot of us here in this room and in this community are working towards these goals by thinking through all of these processes, thinking about how to enable funding to come to all kinds of efforts and groups that are doing work in science, doing work in technology building. We're creating new incentive structures to do that technology translation. We're participating in the public goods ecosystem. We're creating events to enable a lot of people to hear about these ideas, present some of their projects, and so on. And we're kind of trying to create a dramatically better kind of funding staircase for all these public goods type processes. So it's a lot of work going on in here, but I think it's been a lot of people have been talking about this, and events like Shelling Point and Funding the Commons and others are really great for that conversation. I'm going to give a different example today, which is looking at the Filecoin Green project. I think this is a great example of using mechanism design as this massive lever, breaking down a massive scale problem into the pitch of this talk is planetary scale problems, right? So how do we break a massive planetary scale problem into smaller bits? And the Filecoin Green project is a great example of doing this. So I'll tell you a little bit about Filecoin Green first, and then tell you how to go from a smaller problem to a larger scale problem. Filecoin Green is a project to decarbonize Filecoin, and in so doing, figure out systems by which to decarbonize the rest of crypto and the rest of the computing infrastructure, and potentially other infrastructure. So we start small. We don't try to tackle the whole thing. We try to tackle something much smaller. Let's think of just the Filecoin network and the energy use within the Filecoin network. Let's measure it. Let's figure out verifiable structures for identifying where the energy is going, what kind of energy is it, and then let's use financial instruments and structures to offset all of that energy use. And ideally, let's try and start applying pressure into the hardware manufacturers to produce better, greener hardware. So that's stuff that maybe will come later. That I don't think there's a ton of progress on this yet, but it'd be really awesome to start shifting those incentives. One of the key things here is to take a large problem, break it down into something that you think will scale well, that's achievable in the shorter term. If you try to tackle something way too big that you just can't make progress on, you might spend many months to years chipping away at the problem, and you want to achieve that growth. By grabbing something smaller that works good enough, that isn't perfect, but is good enough to show people that it can scale, and is already kind of directionally correct, you kick off a movement, and you kick off this broader range of improvement that can happen. So how this project works is that it's building a bunch of different sub-projects and sub-tools that are meant to kind of work together. It's not like a big monolithic thing. It's kind of a modular ecosystem-oriented approach to making this kind of change. It's building dashboards that track the energy use and estimate it. So it doesn't have a perfect estimate. It doesn't matter. It creates a lower bound, it creates an upper bound, it has some estimate. Then using that estimate, we can then go around and buy RECs. RECs are renewable energy credits, which enable you to one of the really cool things about RECs and why they might be better than many other carbon offset type things is that they enable you to show precisely where the energy is coming from, in which grid, from which producer, at which time of day, and what kind of plant it is. So that lets you, in a verifiable way, get a sense of precisely what type of energy is being put into the grid, precisely at the time that you're pulling it out of the grid. And so that there you can have a strong claim that the energy you're pulling out of the grid is precisely the energy you're buying when you're putting in, which gets rid of a bunch of the nasty problems around carbon credits. So carbon credits is a great idea, phenomenal idea to use the financial system to decarbonize the planet. However, if you create a bunch of loopholes, you can end up with a bunch of unintended consequences. There's been a bunch of stories of that in the past. So renewable energy credits kind of solve that problem, solve a set of problems there of like trying to introduce way more verifiability into the picture. I would expect this kind of thing to be scaled, like get to the point where you have machines in the plants themselves that are able to run some zero knowledge computation, or that have like tamper-proof hardware or stuff like that, where you know precisely that somebody's not messing with the estimates and so on. But we got to start somewhere, and we got to create the incentive structures for the whole system to get better towards that. By creating significant rewards for this kind of work, people will progressively get better, will get better and better at doing these kinds of things. So the Falcon project, Falcon Green project, in addition, is like enabling a lot of other groups and people to get involved. So it's enabling individuals who have other ideas or new ideas, or want to pursue some of the ideas that the project has had, to go try them out. And this might be through like different kind of grant systems. There's like a bunch of different grants that the project is sort of connected to, and it's building a whole set of collaborations with a bunch of other groups to kind of follow the path of least resistance towards greater and greater impact. It's also enabling a lot of people, individuals that like are interested in the project or interested in the ideas, to actually get involved. And this is a crucial thing that I think I see tons of projects forget. If you create good avenues by which individuals that are interested in helping you, where they can follow the information, where they can participate, where they can learn about what you're doing, you can turn something that might be like a small project for a small group of people into a massive movement that a lot of people are gonna work on. And so things like meetups end up being really important. Creating the Sustainable Blockchain Summit. Note that it's not the Sustainable Filecoin Summit. Creating a Sustainable Blockchain Summit creates the opening to get a bunch of other crypto groups to show up and also talk about their projects to decarbonize their chains, and how to use that stuff to decarbonize the planet. And so by creating kind of like all these like smaller levers that align incentives with other groups, you start kind of like tackling this larger problem. By the way, fantastic talks from that summit, and can't wait for the next one. There's a bunch of like really good stuff there. And like good cultural, like you can follow and participate directly asynchronously in the network. So that's kind of like the technology behind Falcon Green involves looking at the actual physical machines that are running the Falcon network, estimating the power consumption, and then leaning into the verifiable claims stack that the renewable energy credits community has built, and gluing these two things together, building a market where you can precisely buy RECs for precisely where the SPs are purchasing energy. And so it's connecting a lot of things together and enabling the thing to work fully, and kicking off an incentive structure for the whole network. Now, then the whole social incentive structure part of this is, you're using kind of news and grants and event forming and so on to catalyze a larger scale action in the community. So it's both like incentives directly in the network and for the people that are running the network, and incentives for the broader community to actually have an impact in the broader thing. Now, so let's scale that up. So if we get to decarbonize Filecoin and we can solve that as a problem, we can then start scaling it up. We can work with other chains that are doing the same thing. We can talk to other chains about how to approach this problem. We can give them a bunch of the technology. We can encourage them or incentivize them to do this by saying, hey, look, our chain's way better. It's way not only can we get to carbon neutral, we can get to carbon negative. One of the things that I want to get to is like be able to say that Filecoin is like, I don't know, 5x or 10x carbon negative in an area, so that whenever Filecoin is there, it is actually like pulling carbon from the atmosphere around itself for that nation or something like that. Like that, I think that would be pretty awesome. And if we can do that, then we can incentivize a bunch of other groups in the blockchain space to do that. And then if suddenly all of crypto itself is doing this, and we get rid of this like mistake in our past of like having produced the big massive energy waste that Bitcoin is, and we can not only offset all of the other chains but also Bitcoin, and we make all of crypto not only carbon neutral but massively carbon negative, then at that point the whole world is going to start paying attention, and suddenly other industries, entire other industries will be incentivized very strongly to catch up to the crypto space. Once you get a bunch of other industries incentivized to catch up with the crypto space, you can then finally get to a point where enormous large groups are getting to be carbon negative, and we can kind of unwind this like crazy set of emissions back down. So I think like all of this is start with like massive scale problem, break it down into smaller groups, and find ways everywhere along the way, from the small scales to the medium scales to the large scales, of creating incentives by which like you cost coordination, you lean into competition, so collaborative competition. You want to get the different crypto communities to be competing with each other of like who's the greenest blockchain, because that's what's going to get crypto itself to be very green. And then once crypto itself is green, then we can compete with the other industries about which industry is the greenest. And so you want to use these kinds of like highly collaborative, competitive, open environments at every stack. So that's kind of like an approach to solving a large scale planetary problem. Now, of course, like there's an enormous amount of work in getting this done. There's all kinds of systems that we need to improve, all kinds of systems that we need to design and build and so on. All kinds of processes that we need to kind of like refine, make verifiable, and so on. This is an area where all kinds of tech is going to, from the crypto space, now in a different angle, all kinds of other really amazing improvements in the crypto space can help this kind of computation. So all the zero knowledge proof stuff, all the verifiable computation stuff is phenomenal for this kind of thing. This is this kind of problem and many other problems in the world have a kind of crisis of incentives and trust, where you want certain parties to take certain actions, but ideally you want to not have to trust them. You ideally want to be able to provide a verifiability layer to what's going on so that you can trust the entire process and the entire system. I think like all of the zero knowledge proof type of stuff can come into all kinds of facets of broader industry and broader world activity to improve how those systems work and enable you to create financialized structures that actually work. One of the big kind of points of contention that the broader mainstream world has on financializing the solution of problems is that it's very easy to kind of warp the incentives and end up with all kinds of unintended consequences, or just like bullshit claims outright, where like parties are lying about the stuff that they're doing. But that's where verifiability is really important. Be able to create verifiable structures that keep removing sources of potential problems. So I think like all the deep cryptography work that is going on in zero knowledge proofs, it's going to be like a very large lever at solving a bunch of these problems, because you can take those kind of verifiable claim type structures, weave them into these larger industries, and then kind of then at that point really financialize them and scale them in massive scales. One thing that's going to help here, and I don't have a slide for this, is certificates of impact are going to, and there's other talks about these. I do think that once we have these verifiable claim structures, certificates of impact present a way to financialize almost anything, which is an extremely, extremely powerful primitive. So we'll see a lot of that stuff coming out over time. One other thing I want to reflect on is the Filecoin Plus incentive structure is really, really useful. It gives us a way to incentivize the gathering, collection, assembling, cleaning up of, and making usable. It enables us to identify a bunch of data sets that we can collect, gather, improve, and refine, and so on, and make usable. And so we should be using these incentive structures to go after massive scale problems. So for example, think of massive scale data sets that could be really impactful in certain problems that are really big and really expensive and really hard to deal with, or that are really far away from being able to make verifiable, or are very disconnected from the economy. You can start doing things like think through some really important data set that you think is going to enable some kind of financialized way to solve some major problem in the world, and say, okay, great, like what's the data that we need so that we can get a bunch of speculators to speculate on the prediction market about what's going to happen. So for example, I'll go to this first and I'll return. Think of like being able to make claims about the planet. So there are data sets like Landsat. Right now, Landsat is not really connected to the crypto economy. I don't know if hedge funds trade on this, but I'm sure they trade on all kinds of activity that is totally viewable through Landsat. So if you had like a real-time connectivity to exactly what's happening on the planet, and you had blockchains being able to act on that data right away, and you had like massive scale bets going on precisely what's going on, and you had a verifiable way to look at it, then you can start making certain kinds of trades possible, and at that point you can then start warping the incentive field to achieve the outcomes that you want. So this might be ways of like holding groups accountable for certain actions, or this might be ways of like responding to certain problems, or it might be ways of like settling important forecasts and predictions, right? So the crypto world has, not just the crypto world, but a lot of groups have pointed out that forecasting of massive scale problems could be greatly helped by prediction markets. Unfortunately, prediction markets aren't quite allowed in a bunch of places. That's a bummer. In the crypto space, there's going to be a lot. I'm guessing there's going to be way more user prediction markets, and so hopefully we might end up with like prediction market DAO things that are able to take significant bets about cases like this, so that we can understand what certain actions are going to do in certain regions. So you can then, at that point, get a lot more information about certain kinds of problems. Prediction markets are an extremely useful structure because they let you build a lot of trust in specific actors that get extremely good at predicting the future, so that you know ahead of time how much you should trust certain kinds of possibilities and proposals and so on. So all of this kind of data, Landsat is pretty big, especially if you want to get like higher resolution imagery, or you want to get not just like visual imagery, but you want to get all kinds of other kind of data about the world. Especially, once you there are these massive scale data sets about certain, like the actual ground, for example, like massive mining companies have to generate like insanely complex, huge data sets about all of the telemetry data they're gathering in certain regions. All of that data you could bring into Filecoin. You can use the Filecoin Plus incentive to just cause all these groups to gather that data. You can then, once you have the data, connect it to smart contracts and then financialize it, which is super, super, super interesting. Now, the stuff that is going to enable a lot of that stuff is, I'll say it for the 50th time today, the FEM. The FEM is going to enable that kind of layer to emerge, because kind of like what we've been missing is the hook where we can start creating computational networks around Filecoin, right? So Filecoin right now doesn't have smart contracts. Once it does, you can create schedulers and then start doing data pipelines around all of this data. So the missing piece is like, so you can bring all that data into Filecoin. Now you want to connect it to a smart contract, and you need the ability to run arbitrary code in ideally a verifiable computing sort of way. And so like that's things that are gonna happen over the next 6 to 12 months is building out all of these kinds of computational networks. So things like, and when you think about like Filecoin storage providers, they have these massive scale deployments, and they already have a bunch of GPUs. That's precisely what you need to build a massive computational network that can operate over this whole data and that can run all the expensive proofs for this kind of information. So this kind of thing of like taking a data set like Landsat and thinking about a certain kind of action that you want to incentivize, and building all the incentive structures around it, needs these like two missing pieces. One is like the smart contract layer, and then after that, like the ability to run verifiable computation over that data set. And that's coming really fast. That's going to be here in the next 6 to 12 months. And at that point, you can put all these pieces together and get that kind of action. So this is one example data set. There's probably hundreds of these kinds of example data sets. So we're building these massive levers to like move mountains and move the world. There's all kinds of different kinds of use cases that we could lean on. Probably should have some conference about this. Like, what kind of large scale problem is connected to some massive data set where gaining the ability to financialize that would produce some major positive impact in the world. So maybe like a to-do for the future. Like maybe another CryptoEcon day could focus on what massive scale problems can we solve with CryptoEcon. Great. So I think probably the last thing I'll mention here is that at the end of the day, like the tools that we're building will only be successful if we can get them into the market and used by large groups of people. So that means, again, breaking down a massive scale problem into smaller and smaller and smaller pieces, starting with that construction, creating an incentive structure that enables a lot of other parties to come in and contribute. You want to use collaborative competition because that's a very useful structure to cause many other groups to go as fast as possible towards some goal. You want to, again, be very careful about the incentive structure you design, because if you screw it up, then you get the Bitcoin proof of work waste. But if you can do that from smaller to larger and larger structures, then you can truly move mountains and you can fix the planet. Great, thanks. And I don't know if there's time for questions, but I think the time's up, so I'll stop here.
Thanks, Juan. After a talk like that, there's always time for questions. Questions to the speaker. I'm going to go back.
Yeah, I think the question I have is who designs these incentive systems, and that centralizes the power in one way in their hands.
Yeah, so I mean, I think blockchain networks are vastly more open about this than like you can propose a design change to a blockchain in a way that you can't to a financial. You can submit a FIP, you can submit an EIP. You can't do that to the U.S. government or to the IMF and so on, right? Which is kind of like wild. So I think there's all kinds of structure that can and should be improved across all these systems to get to a better spot. I think CryptoEcon in particular, there's like all this complexity because you're designing incentive structures. There's all kinds of groups that will benefit or lose from certain mechanisms, so it very quickly gets heavily politicized and problematic. But if you can kind of like remove that as much as possible, or get to a spot where like there's common knowledge that certain things are really useful broadly for the network and align with the long-term mission, then you can build significant agreement in those networks to get that kind of change happening. A good example of this is the Ethereum community is just filled with moments like this that it had to kind of break through, and it shifted its own economic structures. Sometimes, like the move off of proof of work into proof of stake is like a massive one that they've been doing for years. It's a huge economic shift, but the community had enough interest in that to cause that kind of shift. But these blockchain networks are dramatically easier to change in this way. There's probably in the machine learning way, a hyperparameter optimization thing that we could do here, which is like, how do you create way more CryptoEcon activity happening, and you kind of create a much more robust study of all these systems. I think right now, we know this in the Falcon community, like the level of rigor that we bring to CryptoEcon is way higher than many other groups. And even when you put all of that together across the best groups and all of them, that is probably way lower than what we want. We ideally want something 10 to 100 to 1,000x better than whatever we have going on. And so finding ways of doing that might be really good. Potentially might be like causing there to be 10 to 100,000 more 100x more people going into studying CryptoEcon. We might start with a CryptoEcon textbook. I heard that said before. I think David who helped design a lot of the Filecoin CryptoEcon, I think said in the past, like, oh wow, this is like super powerful. It took me a while to learn this. It'd be great if somebody wrote a CryptoEcon textbook so that a lot of people could like have a much faster path at understanding the what you need for the mechanism design. Because you have to learn a lot. You have to learn a bunch of game theory. You have to learn a lot of distributed systems. You have to learn a lot of cryptography and so on. And you end up in like pulling pieces from a bunch of things that to actually get to CryptoEcon. So there's like a good high leverage thing for somebody to do.
One more?
I feel like I've had a lot of conversations this week about privacy and anonymity. I think there's a lot of people that value maximizing that in the Web3 ecosystem, and yet we're looking at like planetary surveillance maximalization as well. Like, do you ever wonder if, what are your thoughts on anonymity, privacy maximalization potentially being anti-progressive in the context of what you're talking?
Yeah, it's a huge problem, and it's very complicated. So maybe like in the most succinct way, I would say that we're an integrated system. Like the idea that there are individuals and groups and so on is like useful fictions for us to like operate. But at the end of the day, you have like this massive integrated system. When you go down to atoms and so on, and so you end up in a situation where at various layers of the stack, you want to have a different part of that solution. For example, at a planetary scale, it's pretty important for the whole planetary community to be able to understand what's going on with the planet, what nuclear tests are happening, what emissions are happening, and so on, what oil spills are happening, what trash is being spilled into the ocean or picked up or whatever. And maybe even at the range of a city, you might want to understand what kind of like problems are happening in certain streets or whatever. Like think of Europe is filled with like CCTV all over the place. Like walking around Amsterdam, you can see all the cameras. I'm sure that they reduce crime. I'm sure they also violate privacy. I'm sure that they also create the conditions by which you can do digitally totalitarian things, and like that's terrifying. So it's a really hard trade-off. I think where I sort of land on this is the more you can create, you can agree on the policies and the preferences and what is a good mission, and the more you can kind of enforce the technology to follow that and only that, and limit the scope of potential misuse, the better off you are. And so that means leaning into verifiable computation, leaning into homomorphic encryption, leaning into all of those kind of privacy-preserving techniques that still allow you to, as a group, compute on something together. You don't have to have access to the CCTV camera things. You can have ML algorithms figure out like, oh yeah, this is a probable problem, and then at that point decrypt. So that's like an example kind of use case. But I think this is a deeply hard question that is going to have very different answers at different layers of the stack, at different points in time, and in different societies. And it's extremely hard to predict what's going to yield a better outcome because it's highly dynamic. The world changes a lot and changes really fast. And so today we have a lot of peace and prosperity globally relative to many points in the past. But that could change. And if it changes, then we might feel very differently about a bunch of these structures. So
I think we're running out of time now, so if you'd like to ask any more questions, you may get to do that at the social hour after this meeting. I'd like to thank Juan one more time for allowing us to end on a very high note at planetary scale, and give another shout out to all of our presenters today, and for you, the audience, for your questions and your thoughtful attention. I hope we've convinced you that Filecoin CryptoEconomics is a really fun sandbox to play in, a really cool and very powerful system to explore some very deep questions, and that maybe we've attracted you to come play with some of our toys. And now we'd like to invite you to socialize a bit and to chat about some of the topics we discussed today below in the atrium level at the social hour. Thanks again to all the presenters, and cheers.